Let's start this one more time.
Okay.
Welcome to the Making Awesome podcast, episode 187, where Grant's going to have to do editing. We're joined by the team at Rack Robotics. We've had some technical difficulties. If you weren't watching live, you have no idea that this even existed, and we had any of these issues. We are joined by Nick, Cooper, and John of Rack Robotics. They make affordable desktop wire EDM. So I'm going to have you guys redo your entire intro. Give us the backstory, boys, the who you are, the where you're from, the what you did, and as long as you love me.
All right. So I'm Nick. I'm the CEO here at Rack Robotics. Background physics, mechanical engineering, a lot of fun stuff that's not software engineering, which is I do a lot of our software, ironically.
Yeah, Nick built like a 4-axis cam suite
in about a month.
Yeah. So
wait, seriously?
Yeah. Oh yeah.
That's freaking dope.
It's simple. It's real. It's not Fusion 360, but it does G code, which is the important part of whatever you need it to do.
So you can like export an SVG of the thing you want to cut out, and then drop it into our CAD cam suite.
Let's finish up our intros.
Anyway, yeah. John's distracted. Fun fact: John will get distracted constantly. But yeah, so I'm a mechanical engineer, CEO, simple stuff, doing software and business stuff.
Right. Hi, I'm Cooper for Rack Robotics. I'm co-founder and COO. I do a good portion of the mechanical engineering design, and I handle a lot of the fulfillment stuff around here. Previously, before doing electrical discharge machining, I researched electrochemical machining for desktop machining. There's a YouTube video that's still up where I cut through, I think it was like 6mm hardened 4130 steel. And John can tell you more about his experiences with electrochemical machining before we really got into electrical discharge.
So I'm John. I'm the CTO at Rack Robotics. I actually am not trained for anything I do. All my schooling is like chemistry, biochemistry. Previously I wanted to go into a career in drug discovery, so like finding new antivirals and new anti-cancer drugs. But I gave up working on a cure for cancer to start Rack Robotics.
Drug discovery lives in Colorado.
That's right.
No, like actual drug discovery, the real kind.
Not walking around the forest.
Discovering.
Yeah. So I really liked electrochemical machining because it was very simple to do. Electrochemical machining is a little bit similar to EDM, where it's a low force, non-traditional machining process, but instead of using electrical sparks, it uses electrolysis. I gave up on ECM because it uses salt water. Salt water is the bane of my existence. Salt water will destroy anything mechanical, anything electrical.
Yeah,
we destroyed
not a fan of things.
Yeah, we destroyed like 4 switch mode power supplies and a bunch of robots, putting them next to salt water, into salt water, various salt water combinations.
Pouring salt water all over top of their motion component.
Yeah. So
what could go wrong? I see no way this could ever go wrong.
No.
So
it's fine.
We wanted to get out of electrochemical machining many years ago, but there wasn't anywhere to start. And then this German guy named Dominic Meffert, he's quite a character. He builds all sorts of stuff in his garage, but it's things you'd never expect anybody to do, and then they're things that generally people have never done. So he's building like a continuous inkjet printer out of like plumbing parts right now. He's been working on that for 2 years. But before that, he worked on EDM. So he built like a really interesting, simple wire EDM power supply. And then we took that and we started modifying it, improving it. And that became the PowerCore V1. And then we kept modifying and improving it. So now we're at the PowerCore V2, which is, as far as I know, the world's most compact, most affordable, and potentially one of the world's most power efficient wire EDM power supplies. And we've used it for wire EDM cutting through steel, stainless steel. We've cut titanium. It's graded aluminum, and Cooper's also had a lot of luck
with die plunge EDM. So it's a single axis sinker type machining. I don't know if you'll be able to see that.
Oh yeah.
That's AR500 steel, which is an extraordinarily difficult material to machine. But we can plunge cut a profile right into that.
Just stop at difficult steel, because it's just difficult for everything. Yeah. It's difficult to cut.
AR
it's
means
difficult
abrasion
to machine.
resistant.
It's literally like I have some because I live in Florida, and of course I have AR500. It is often used as steel targets for.
Yep.
Let's go with freedom delivery units.
Yes.
Yeah.
So that plate of steel will block 308 bullet, but it won't stop an EDM electrode.
Right. And we also can do the same thing in titanium. So, you know,
You're
really,
looking
we
like you're
have,
making the Mandalorian thing, making a thing of Beskar over there. That would be super cool. Make an electrode
if it was
to
real.
do it.
If it was real, we could do it.
I mean, look, all right, everything is real if you care enough. Okay.
So, well, that's an
Just
interesting
gotta
tangent
believe.
to hit on, right? Because the plasma that's generated by an EDM power supply is as hot or hotter than portions of the sun. So you can work with it.
It's only mildly spicy. Yeah.
Right.
Well,
So-
what's really cool is it'll vaporize metal, but it won't touch skin because your skin is a million times your skin has a million times more electrical resistance than the thing you're cutting. So when it hits metal, it dumps a ton of current and it vaporizes the metal. But if you stick it in your hand, and I do this all the time in videos,
I watched you do it. It made me very nervous.
And don't replicate this.
Yeah,
But-
literally, if you try this at home, the chances of you unaliving yourself are non-zero. I want to be clear about this.
It's not zero. That's an
Right.
important.
Yeah, it's a
number.
non-zero
There's an
chance.
end-user
Yeah.
license agreement you have to comply with. It comes with every power core. It says you won't do that.
Then literally
But,
goes out and shows that you can. Cool.
Right. But like, I can't do that demo with an actual CNC mill. If I put my hand inside a CNC mill, it's going to tear my hand.
Wait a
off,
minute,
but I
wait a
can put
minute.
my hand
You
inside
can
it,
do it, just only once.
Yes. Yeah.
Twice. We can do it twice.
Oh, that's fair.
Most people
Twice.
twice,
That's right. Because if you could do it
Right.
3 times, it would be a lady, as far as Lionel Richie has taught me throughout the years.
But like, so those are some of the advantages of wire EDM. Is it's not going to rip your hand off, and then if you break something, you only break brass wire.
Yep.
Versus when you're operating a CNC mill and you break a tool, you could be out $100 in 2 days of time waiting for a replacement end mill to show up.
Oh,
But
easy.
with wire EDM, there's no end mills to break. And I think that's one of the reasons why it's poised to take over sort of the hobby market for like making metal parts at home.
Yeah.
Because the consumables are orders of magnitude cheaper, and you don't have to keep like 100 end mills on hand.
Not to
That's-
mention work holding too. Work
Yeah.
holding is so easy with this because it's such a low force process.
Yeah,
You can
the
use
system
some
doesn't
water
move
resistant
fast
friends.
enough to need like 18 different clamps at 10,000 pounds worth of pressure. It's a slow process.
Well,
How
it's just
slow?
little microscopic sparks blowing away small bits of metal.
Yeah, there's the machine actually sees more force from the dielectric water flushing than the actual EDM process. So we have like a 100 psi like RV pump, $20 to $40 off Amazon, and that's what does our dielectric flushing in it. So when you're doing the cutting and you're vaporizing the metal, you need to get rid of the metal as fast as possible. That way you
Right.
can continue cutting. It's chip clearing. And so the way you do chip clearing in EDM is just with like 100 psi water. So like a pressure washer would be overkill.
Yeah, you're
Yep.
literally just using a low pressure washer to literally wash the chips away.
Yeah, and then some people have asked about recycling the water. Obviously, you're vaporizing the metal goes into the water, it cools, and it becomes metal powder. So like at the end of the day, you're turning like solid metal into tiny little bits of metal powder, and then the metal powder goes into the water and it can make it dark.
How fine
the
of
way
metal
we get
powder? Could I like recycle it into a DMLS printer?
We actually have some people who are interested in that.
That's pretty cool.
So what we're doing is we're scaling EDM. So we're going to be offering enterprise solutions to like universities and factories where they could get like 100 wire EDM machines on racks, like almost like server racks. And, potentially as a byproduct of that, doing that in massive parallel, you could produce a couple kilograms of metal powder a day.
And I would actually really like to
Jeez.
try out the steel powder for that DMLS process because it should have brass in it, because it's eroding the wire and it's eroding the workpiece. So potentially that could be easier to actually, laser sinter versus just plain steel by itself.
Yeah, so it's
like brazing.
It's an interesting problem to look into, but ultimately, if you want to recycle your water, it's just distilled water from Walmart, so it's not that terrible if you don't want to recycle it. Like you're out $5, but if you do want to recycle it, you can get like 10 micron filters off McMaster Car for $10.
Could you just use?
And they
So
also-
Yusuf is asking, could you just use a magnet? Could you use like an electromagnet that will attract all that metal powder? Then when the cut is done, turn off the magnet and the powder settles down into a little basin that you could then take out.
We've definitely done some steel machining on magnetic steels,
Mhm.
like this AR500, and the majority of the waste material is not highly magnetic when it comes to steels.
Then you probably can't sinter it. because at that point it's likely fully oxidized.
Probably.
So
Yeah, that's probably true.
I was gonna ask if the chips become basically rust, and it sounds like they do.
Well, it's not like because you don't get a rust patina in the water,
Right.
Well,
wouldn't that be iron oxide 3 that turns black? It's
There's some weird chemistry you'd have to
I have
look into.
business
Okay,
degrees.
you should one thing that's really important is like a lot of people will tell you that EDM is a thermal erosion process. If you read on Wikipedia, it is not a well understood like science.
No.
Like people like thermal erosion is the easy answer,
Yeah.
but it's not the actual, like the models that people use to define it as thermal erosion have assumptions that are not necessarily required.
And there actually hasn't been very much research in detail on EDM because there isn't a way for academics to get their hands on these machines readily, and
Right.
there's almost no way to replicate. So if I have wire EDM machine A at my university and another university has wire EDM machine B, the research I do is often not applicable because like the machine parameters are different, and it's not like the machines are open source. Like I can't say I was using this exact circuit on my wire EDM machine. So like wire EDM research is held back in that regard, and we've actually gotten a lot of outreach from universities that are working on EDM that want our power supply specifically because they can share it between institutions. Like one university wants to purchase like 10 of our units, and then another university wants to purchase units for their labs. You know, we have interest from Purdue, we have interest from University of Sacramento.
Yeah.
Where, as far as I know, this is like the only way to do wire EDM research that's like easily replicatable across institutions, but also modifiable. So because our power supply is open source, academics can really get into modifying the power supply to like change like very specific parameters in what they're doing, or to like get more control over the process.
Yeah, and in that way, it's actually really exciting because being able to replicate those results and being able to do a lot more in the way of just like total research on EDM will, I mean, I hope really push the field forward.
Yeah. I think CNC Kitchen actually had a really funny tweet where he was talking about the quality of like FDM papers he came across, and they were really lacking.
Yeah.
So, and then you compare that to like the quality of like a Stefan CNC Kitchen video, and they're great. He is like, he's doing like 40 different samples, and he's running them on like machines that he's built and calibrated, and he's collecting really good research. And I'd love to see that sort of thing happen 10 years into the future with wire EDM YouTubers. Like I like to think that if we continue down this path, then there's going to be like a wire EDM YouTube community the same way there's like a 3D printer YouTube community.
That would be really awesome to see, because like I don't have a ton of experience with wire EDM. I've worked on and been around the electrode style EDM where they're cutting out of, generally it's like graphite or carbon, and then they're just and just beating it into the metal effectively with electrons. And first off, freaking cool. And it's one of the mold shops that we work with locally. They use it to make really, really fine detail molds for injection molding. Right. And because this process is effective, it's relatively clean, and it is precise. And the precision is the big thing when you're trying to do really fine detail work. And like, okay, you can go get a fiber laser and cut metal, right?
Sure.
But you ain't getting a fiber laser of any value for even on your top end. The latest fourth axis one, you're looking at about a $2,000 price point, right?
Yep.
Yeah.
Those lasers are going to really struggle with even thicker aluminum.
Right.
So like if you want to cut 12 millimeter thick 6061 or 5052, you're going to get like dross, and you're going to get like tapers.
Taper.
Yeah. So with wire EDM,
yeah,
you don't
it's
get
going to be away from the galvo.
And then also consider how much heat deposition you're putting into that material.
Yeah.
Like
you can warp
take
it.
In wire EDM, you don't have to worry about heat almost at all because you have so much water there to deal with the thermal management.
Yeah.
But on a laser, you can't. Like if you stick the thing in water, then it's like, oh, now that cone that you had is now you have a weird refraction problem.
So
like the actual energy input for EM is much lower than comparable like laser capability. You're just going to be looking at a much higher energy per unit area.
Also, we found that there are less resources involved in building an EDM machine, like a wire EDM machine on a desktop scale, than there is building an optics train for a laser. So like
yeah,
me and
I
Nick,
noticed that.
yeah, me,
Your
yeah,
machine was very simple. I'm like,
there are
this is
fewer parts in
simple.
it than a boron.
Really?
Yeah, I think there's like 50 fasteners total on the entire machine.
Wow. I see, like that's something to think about, right? Because like we don't work a lot with metals here, right? If I work with metals, I've got a buddy that I go to and play with his, DMLS, LPBF technically, but fine, titanium 3D printers, and they have a wire EDM, but they also have a dozen metal printers, so they don't care. Their budget is who gives a damn. But for the small business, and I would say small to medium, but the way the U.S. classifies small businesses, it's like under $5 million is a small business. So for the small business out there that's looking to get the use case of a wire EDM, this would be a great way to validate something and put a real product into production
Totally.
and not have to drop 50 grand on an idea.
Well, and then we also have people who come to us almost every day, who have like small and medium sized machine shops, and they just need wire. Like if they had a desktop wire EDM machine for like trimming down hardened steel stock, or like people come to us and they say, I have this hardened steel tube. I just need a way to cut it in half, and right now it's taking me 4 hours to do by hand with an angle grinder.
Yeah.
And like one of the big selling points for us is that the cost of purchasing one of our machines is often just less than like the time you would invest in like trying to angle grind a piece of hardened steel in half if you own a business, or it's significantly, sometimes it can be less than just getting one sample part from a wire EDM shop.
Yep.
Yeah.
The same, and that's not uncommon in even the 3D printer world. Like if you went back in time 15 years and you wanted to get a sample part 3D printed, it might cost you more than like an Ender 3 costs today.
Sure.
Oh, yeah, it still does, to be clear.
Yeah.
Well, at shops that actually value their time, but that's a different podcast episode.
How many wire EDM, how many 3D printers are there being brought into the US every year, Nick?
1,004,000-ish.
Well, it's a lot less than the next couple of months, but yes.
Yeah, yes. But historically, and that's making a broad assumption that like the United States, like per capita, consumes as many 3D printers as like the rest of the world, which is probably a bad assumption. On the like,
it's likely
low,
higher.
like it's probably, like 1,004,000 is on the low side.
Recently in a YouTube video, I mentioned that EDM was a rare technology, and one guy commented something like, "Well, I went to this large machine shop and they had 10 wire EDM machines. I don't think it's all that rare."
Right.
It's like, well, how many 3D printers do you think there are in the United States? Literally millions.
Mm-hmm.
Hundreds of thousands are brought in every year to every couple months.
Yeah.
There are dozens and dozens of companies making 3D printers because they're extremely useful tools, because you can set one on your desktop and you can make a useful part in an hour.
Yeah.
There's no reason, like physically, thermodynamics wise, there's no reason that EDM can't do the same thing. Like it uses fewer parts. The only thing you're doing is adding in an aquarium full of water.
So the classical limitation for EDM machines is that they're like a 10 to 20 year purchase. So you're going to amortize that over 10 to 20 years.
Right.
So the machine has to be able to handle every single part that you can throw in, but for 20 years.
I can amortize this out in 20 minutes.
Right. And that's a good deal if you're a machine shop. Like 500 grand for a machine that you're going to use for 20 years, cool. But like that's a pricing model that works for large industrial tools that can do everything. Mm-hmm. But oftentimes people just want a tool that can help them get a prototype out faster, or they want a tool that can help them do a simple job. And that's why desktop 3D printers dominate. That's why we have hundreds of thousands of them. And wire EDM can scale the same way.
It's literally some in this room.
Also, something that people don't talk about enough is generally just electrical infrastructure.
Yep.
Like somebody reached out to us on Discord yesterday.
I saw that tweet.
Dude, could you imagine actually like impeding your local branch of your electrical grid because you run your machines or not? Like your utility provider needs to know when you're running your machine so they can load balance.
Because you're using that much electricity. And you're ready for some deep lore on wire EDM.
Oh my goodness.
Oh, here's a dirty secret. Those wire EDM machines consume a ton of power, those legacy wire EDM machines, but they aren't using it to cut metal. I did the math, like the basic physics on how much energy is required to like slice a block of steel in half. It's not that much, and we've proved it. Our power core draws like typically 200 watts of power, and most of that goes towards cutting. so the reason why these gigantic legacy wire EDM machines draw so much electricity that they impede your local city's grid is just because of, one, they have gigantic hydraulic servos, two, they have gigantic water pumps for various reasons, and then three, the water pumps are so inefficient that they heat up the water, and that poses a problem to cutting. So they need a refrigeration system. That's three. They need a refrigeration system to cool the water after needlessly heating it up. Yeah. And that's like 5 kilowatts of electricity on top of like the 200 to 500 watts needed to do the actual cutting. So most of the energy is just being wasted. Like you could run our wire EDM machines, you could run our power core off a solar panel.
Yeah, we talked a little bit about the actual power supply, and David Connor Shover says, I hope you put a lock on that power supply patent. By the way, no wonder why I kept losing cell service around the food court. I don't know what that joke is about, but huh?
No, so like we'll talk about this briefly, but our wire EDM machine runs on Wi-Fi. We control it all over Wi-Fi. We control it with our phone. It's really fun. Like there's so much. This machine puts out orders of magnitude less EMI than a conventional wire EDM because the interconnects are shorter, and we optimize them to not put out EMI. Like we use a lot of twisted pairs and shielding.
Yep.
I did notice some at the show. For reference, anytime that I was near you guys and you were running the machine, our mics would cut out.
Honestly, that could have just been the hand demo.
Yeah.
The hand demo.
Oh yeah, it's probably the hand demo. That's
very
high pitched whining.
Yeah, it's extremely high pitched, high impulse sound.
Yeah, and our mics are all RF controlled, so I'm sure it was just overloading those RF frequencies with just a bunch of EMI.
Have you seen on when you try and film it up close on the camera,
Mm-hmm.
the sparks are high intensity and they're so fast. They're like 32 microsecond sparks.
Wow.
That it will like you can see the shutter on the camera.
Yeah.
Like the rolling shutter.
Oh yeah, you can get the rolling shutter effect. Yeah. I got B-roll of it somewhere. I will have to check because I want to be able to film stuff like that, but I know pretty much as soon as you start, that water gets cloudy. And you guys have
Unless you're filtering.
Huh?
Unless you're filtering it.
Right. And I could use like an aquarium filter or something, but that's going to get clogged pretty quickly. But
so we found that 10 micron filters work, and you can either get like disposable paper filters for real cheap, but you can also use like stainless steel reusable filters. So when the filter gets filled up, you just take it out and you wash it out.
Yeah, just like a fine mesh screen, basically.
Mm-hmm. Yep.
Okay.
You just wash it out with the same dielectric you're using for cutting, just to keep it all consistent.
Which is distilled water.
Correct.
Yes.
Yeah. So distilled water is not technically, I guess it is dielectric. Yeah, that makes sense.
It is. It's an insulator.
Yeah. It
so
is
water,
an insulator.
Water doesn't conduct electricity. That's a common myth. It doesn't conduct electricity. Now, when you're talking about electricity will do weird things. So at very, very high frequencies, you can get like skin effect. You start worrying about like the capacitance of a substance allowing AC to flow. But like for pulse DC, it's an insulator, and that's why it works, because the water set between the electrode and the work, eventually the electric field becomes so strong between the water that it strips the electrons off, and that's when the plasma forms and you do your cutting. But if the water was always conductive, so if it was salt water, for instance, you wouldn't be able to do EDM in it because you wouldn't be able to build up that electric field between the work and the cutting electrode.
Interesting. And you guys are running a relatively low voltage power supply as far as wire EDM is. And before we get too deep, it is open source, right?
Yes. It's actually on GitHub right now.
That's part of the deal, right? You guys are not only developing something that's affordable, you're giving the middle finger to the big companies out there saying, yeah, we're just going to open source it. Have fun.
That's the idea.
But what kind of voltages are we running?
So our stock output is 65 volts.
At how many amps?
So that's the thing.
Yeah.
The amount of current that it puts out is dependent upon the resistance of what you're cutting. So when you're cutting metal, you can get like 200, 100 amp peaks. But like if you have like your hand in there, which is a gigantic resistor, then you're going to get very, very little current flowing. So the amount of current that the power core puts out is dependent upon the resistance of what you're cutting.
Interesting. And so
like John said, at the spark actual initiation, talking well over 100 amps
Yeah,
in
and
that
that's
one spark.
and that's with about a 1 ohm load. So that's like the resistance of like the EDM spark gap is about 1 ohm.
That's a lot of watts.
Yeah, but the
But
average
for like
is,
very, very
Yeah,
little
yeah,
amount of
it's
time.
picosecond. So your filtering caps or any bus capacitors that you have are eating up that load.
yeah,
Are you?
that's what's special about the power core. So the way the power
Mhm.
core works is it has something called a peak current mode controller, and so that puts out as much current as like our system can for a very brief amount of time to charge capacitors. So if you look at it on the oscilloscope, it'll like hit a big peak, a big peak, a big peak. Do that a couple times to charge up the capacitors, and then once the capacitors are at your desired voltage that you set in firmware, it shuts the charger off, and then it opens up the output stage. There's a little MOSFET that turns on, and then that's what dumps the capacitor like power into
And
the
it's
work.
just doing that many times a second.
Yeah. So it takes a couple microseconds to charge the capacitors, and then it discharges those capacitors for about 32 microseconds, and then it waits about 512 microseconds for the dielectric to recover. So
we're talking like 2 kilohertz.
yeah, like 2 kilohertz is generally what we run.
So, all right, for those that aren't understanding what's going on, you've probably seen a boxer on a speed bag, right? Where they're just rolling hits. That is what their power supply is doing, but to metal.
Yeah.
And instead of physical punches, it's electricity, right?
Yeah,
so
so it's little microscopic lightning bolts, 2,000 lightning bolts blasting away craters out of metal every second.
Yeah, and so if you look at the
It's
surface
just a
of
fun
like
way to look
the
at
uncut part, you can see many millions of tiny little craters, and they sparkle.
it. Yeah.
And the really cool part about that is, or at least one of my favorite parts about the EDM finish, is that it's actually really fine. So it sparkles and it looks rough, but to the touch, it's very smooth. And after about 2 minutes of like a 2,000 grit sandpaper, you're almost at a mirror sheen for your metal. And that's in aluminum, which is going to be rougher than steel.
Right.
So because you're taking out bigger chunks out of aluminum due to the material properties.
Yeah.
But if you did that with steel, you'd be getting an even finer finish faster.
So what is the tolerances then of the wire? And I know that has a lot to do with the wire tension, because less tension, the less tolerance you're going to have. But on a relative level, let's say I was going to cut a 20 millimeter square out of let's just go with regular, like mild steel, something generic. What kind of tolerances are we working with on the wire?
That's a really good question. In terms of the power supply, like the power supply can hit probably a couple microns tolerance.
Wow.
And everything after that is just the kinematics that you're using to move around the wire. So if you put like a wire EDM tool on an Ender 3, you're going to get Ender 3 tolerances. If you put a like well-designed wire tool on like a dedicated CNC machine with like closed loop ball screws or something, then you'll get much finer tolerances. So the actual tolerances themselves are really just whatever the kinematics can do, and however taut your brass wire is. And on our first revision of the beta wire, we can do like plus or minus 100 microns, and then the reason that we're releasing the beta wire kit in September, the reason why we're starting to ship it in September, is because we're going to spend the next couple of months doing another revision on the machine and improving every aspect of it, and we're going to aim for plus or minus 50 micron tolerances on the kit we ship out.
Now, what is like the I'm going to put quotes around the big boys, but like what are the really expensive wire EDMs able to hit these days? Do you know?
Single digit microns.
Yeah.
Okay. And so that's
that's a great tool to have.
Yeah.
But for the vast majority of parts that will ever be made,
you don't
like by people, don't need those tolerances. Like
if you're making special kinds of centrifuges that only states can afford to make, maybe that's a good application.
Yeah, your nuclear centrifuge.
Yeah.
That's a good application.
Well, even like dies, like if you're making an extrusion die, yeah, sure, maybe you want to pull a really, really tight tolerance.
Yeah.
But if you're making a part, like a discrete part that goes into a system,
like a metal bracket.
If you designed that part to hold a micron, you have huge problems because thermal expansion.
Get out of your own
Like
head.
the moment that you walk outside,
Yeah.
if that part has to go outside and then back inside, that tolerance no longer matters.
Yeah,
Right.
The newest EDM machines out there have they have extremely precise temperature control systems, and they're fully enclosed. So it's a big machine, half the size of the room we're in, that's fully refrigerated and heated to keep plus or minus 1 C over the course of like 7 to 12 hours.
And it's worth mentioning that wire EDM and plunge EDM are basically industrial inputs for everything we love and hold dear.
Right.
So like this calculator I have on my desk,
Yep.
it's made of plastic, just like almost everything we have.
Coffee cup.
Yeah, coffee cup, plastic. Those were made on injection molds.
Yep.
Injection molds, and those injection molds are fabricated with wire EDM and with plunge EDM. So like everything we own eventually can trace its way back to like a guy in a tool and die shop, fabbing out a mold with a wire or plunge EDM machine.
Yeah.
And there are only a couple thousand, let's say 5 to 10,000 like EDM machines in the United States total. So like if the United States wanted to make if we wanted to make all of our own stuff domestically, in like a time of crisis or war, or if we just want to have a real economy again, wire EDM is a major bottleneck, and so is plunge EDM. And how many wire EDM companies are there in the United States, Nick, domestically?
0 owned by American companies.
Well,
there's a couple
until
like
now,
well,
technically.
Well, okay, one. Us.
One.
I'm like, I know you have funding. Is your funding in the United States?
It's actually all Chinese.
No,
well.
it's not. No.
It's not.
It was a joke. It was a joke.
So like, there is a quick path to us becoming like a national infrastructure sort of by accident. Like if we're developing massively scalable wire EDM machines, like if for 500 grand, a factory could buy 100 wire EDM machines from us that can each hit plus or minus 50 micron tolerances, and we're the only wire EDM machine in the United States, it's a very fun position to be in.
Now, that said, there is Fanuc America, which is a Japanese company with an American subsidiary, right? You have Mitsubishi, Japanese company, American subsidiary. Kent, there's a company called Kent USA, which is a Taiwanese company with an American subsidiary. That seems like it should be an American company, but that is a Taiwanese machine. Sodic. I mean, like all these companies, like
they're either German, Swiss, Taiwanese, or Japanese, mostly.
For the most part, yeah.
Well, I mean, that's where a lot of the electronics are going to be made anyway, so it makes sense that those machines would come out of there. Yeah, it is certainly a different world when you realize that you are an army of one. And I think it's clear to kind of say that small EDM may not be where you're 100% intending to remain. This is more of, it's a trial to verify that what you're doing is correct and works, to maybe look at providing real infrastructure to companies throughout the United States.
I would. There's a huge advantage to having small machines that are moderately accurate, like something that could hit the same tolerance as an affordable CNC machine. If you can afford to purchase 10 to 20 of those, you've got massively parallel operations. Yep. And 99% of parts won't need those like 1 micron or sub-micron tolerance. So
it also opens up like compliant mechanisms to like serial production and like lower end mass production. So if you're a company and you just need like an aluminum flexure for your product because it cuts out 10, 15 other components, like with one flexure, and you want to produce 1,000 of those flexures, it'd be borderline impossible to do that economically in the United States. But on a rack of one, if you have a row of server racks with little wire EDM machines inside, and you had 100 of those and the part took 3 hours to cut, that means that in 3 hours you produce 100 of those parts for a batch of product in a day.
And that's valuable. So we've talked about this before on the channel, where people are like, oh, I just want one fast printer. I'm like, nah, I'd rather have 5 or 6 Toyota Corollas than one Ferrari, because ultimately those Corollas are going to get me to where I need to go faster and more reliably than the Ferrari. Is the Ferrari going to beat us at the finish line? Absolutely. But is the Ferrari going to need a heavy maintenance package? Right. And then there are people who say
you might need to have a guy whose entire job is just maintaining the Ferrari. But
exactly.
If you have a rack of 100 wire EDM machines and one of your wire EDM machines is broken or goes down, or something happens, that means that your production is only decreased by 1%.
Yep.
So there's a huge advantage to massively parallel infrastructure in terms of like reliability and sustaining your production for long periods of time. And it's also portable. So, you could fill up a semi truck with wire EDM machines, or you could fill up a cargo container with wire EDM machines.
And there's a value to it as well, because you're also not running a lot of wattage. So literally having a moving wire EDM business that is in a semi-trailer, then okay, maybe you put it in there initially because you didn't want to have it into your shop, and now you're like, well, I could just take this places. 100 wire EDM machines with what you guys are doing is going to draw what, 2.5, 3 kilowatts max? Like,
it's manageable. It's
yeah,
manageable for a factory.
It's incredibly manageable. But quite frankly, the hardest manageable thing with what you do is the size of it.
Yeah, so
they're not that big, but 100 of them starts to get pretty big.
A good comparison to the power core in terms of like electricity draw is like a heater bed, like the hot plate on your 3D printer that heats up the bed. That's like what, 200, 300, 400 watts. So like that's comparable to the power core. And how many universities out there have shelves with 100 3D printers on shelves for their students to use?
Yep.
And the reason why universities purchase lots of 3D printers is because the students can use them, and it's low risk and it's relatively low cost. And if you were to give like mechanical engineers access to wire EDM, then they'd be able to make metal parts. You know, they can make gears. There are university students who do not have access to custom gears. Where are they going to get them? They're going to have to send off an order some. It'll take 2 weeks. That's a significant amount of time. If you're working on a capstone project, or if you're working on like a PhD dissertation, weeks matter.
Yep. And just going back to the utility of a smaller machine, we've visited a couple wire EDM shops, and I think it was somewhere around 80% of the parts that they make are less than 3 inches thick, and they would fit within the beta wire currently. So they're relatively small parts that they're wire EDMing for the majority of their jobs.
I'd be really curious as to why they're all small. Because, like, you know, honestly, I don't think I've ever seen big EDM parts, wire or standard plunge EDM, at the shop that we work with, because they use the EDM because it's highly precise. They don't.
Yeah.
Like,
Precise
that's why
model.
they use it.
Yeah, I mean, like if you imagine, if you wanted to hold 10 microns on a part that's like a meter long, that's not the part. That part, you can make that one part, sure, awesome, but you can't make the parts that it mates with, right?
Right.
How many things around you are a discrete single piece? Basically nothing. And so if it has to mate with something else, and it's like, oh, this holds 10 microns, but this holds like half an inch.
Right.
Okay, who cares that you can hold 10 microns?
And I was having a discussion with an engineer who builds propulsion systems, and we were just BSing, you know, throwing around ideas. And I said to him, like, if we had the greatest idea now, we wanted to build something, how long is it going to take us to go from idea in our head to part in our hand? And, you know, there are some ideas I've been kicking around in my head that I'd love to try and build. You know, I had the idea 2 years ago, but I just don't have access to the tools to make it. And that's very common. Most people who are like creative, or they work on like mechanical engineering problems, their greatest challenge is generally not it's not that they can't make the part precise enough. It's that they can't make the part at all. And I think that's why JLC, PCB, and PCBWay have a business, is because people need access to basic industrial infrastructure.
Yep.
If I need 100 cables, or if I need like a circuit board, really simple circuit board, or if I need like some aluminum machined parts, that can be a real challenge to the typical inventor in the United States, because I don't have access to a $2 million PCB production line in my own country.
Yep. Yeah, I did. And they've kind of come out of nowhere and been like, hey, we have all this infrastructure. Enjoy it. You can make one PCB if you want, but it's basically the same price to make 10. So you might as well make 10. Yeah.
Well, I've noticed that 3D printers got really good in the past 10 years, not because of like large corporations pouring money into R&D, but because of just the millions, like 1 million people in the FDM community all tinkering away. Like input shaping, which unlocked a whole new level of like 3D printer precision, came from the open source world. Like the Voron project was from the open source world, and that's what Bamboo is built upon. If you go to the Bamboo website for their proprietary printer, they say that they got most of the infrastructure from Voron.
Well, and then you just consider suppliers, right? Like, as there are more 3D printers in the world, more people can make the motors, more people can make the drivers, more people can make the control boards. All of those things become cheaper.
It's an economies of scale game, really.
Right.
Yes, exactly.
So consider EDM now, where there's countable number of machines in existence running every day. How many suppliers can there possibly be for vices?
Yeah. We so the company that makes our wire EDM vices for the beta wire kit also makes vices for Fanuc. So it's the same vice, but we're probably going to be a bigger customer for them than Fanuc,
just by
because
volume.
because we sell more beta wires than Fanuc sells wire EDM machines.
I always thought it was Fanuc. Have I been saying their name wrong for years?
Oh, we could be 100% wrong. We haven't talked.
It's like when you read the name in the book for like three books in the series, and then somebody's like, "No, that's not how you pronounce the
Well,
name."
it's the way it's in my head, damn it. It's the way it's gonna stay.
Imagine
my headcanon.
Imagine walking into the theaters for like the first Lord of the Rings movie and like being like the biggest Lord of the Rings fan, is like, and you look at it like, Bilbo. I didn't pronounce it Bilbo in my head.
John can't read, just so you know. Like John cannot read at all.
Like we said before we got cut off, we're all fully unqualified for what we're doing.
I can do math.
I can add 2 plus 2. It equals 5 for extremely large values of 2.
There you go.
Yeah, but
do you want to take a look at the beta wire real quick?
We can. I do. There is a question though that I want to pose before we go too deep into beta wire. Geocacher is asking, I wonder if you can put an IDEX on an EDM machine. One head is the wire, one head for plunging.
We talk about that sort of stuff a lot.
Because that's pretty effing cool. I'm just saying. I mean, that'd be cool.
Exist like the 3D printer people really proofed out a lot of the tool changer infrastructure.
Yeah.
That would be an interesting idea to do with EDM, wouldn't it?
Yeah. It's awesome how I talk to people about Clipper firmware all the time, and the best way I can explain it is like it's just robotic software at this point. Like if you want to control a bunch of motors, use Clipper. I use Clipper for weird stuff that Clipper should not be used for. My hot plate runs Clipper because I can pull up my phone, I can set a temperature, and then I can select a profile for how the temperature changes over time. So like if I'm soldering, I bought a hot plate off Amazon, I put Clipper on it, and now I have a Clipper hot plate.
Yep.
And Clipper's such an amazing tool. If I want to add a motor to a robot, I just open up the config and I put in a new motor. Right. And I get a whole graphical user interface for free. And then Clipper has all sorts of cool features. You can control servos, you can control LEDs. It has I2C. It'll support Ethernet.
Yeah.
Yep.
And there's also the Danger Clipper devs are really, really interesting guys. We've been talking to them a bit. And they do stuff that the regular Clipper devs wouldn't touch with a 10-foot pole.
Yeah, like
fun.
Yeah, so the Danger Clipper people have been working on like closed loop BLDC motors.
Sounds off your watch.
Oh.
It's 11 a.m. I don't know what the alarm's for, but it's 11 a.m. for you guys.
That used to mean lunch, I think.
Yeah, so at some point in the distant past.
Yeah, me and Clipper are not the best of friends, and I think it's just because it's UI for morons. Hi. It's not great.
Yes.
If you don't have a basic understanding of coding and how to read code, and like, okay, I know that you use the pound symbol to comment things, in and out. Well, if you don't know that, you don't know what the hell you're doing. And there is no, and that's why I love Duet and RepRap firmware, because it is so simple, I can do it. And see, I sit here and say I am that delineation between, I have run multi-million-dollar machines. I've also built 3D printers from scratch. There's a big D-bot sitting right off camera. But I also don't know how to code. So
that's something we were talking about as an interesting idea for Clipper previously, was like a drag and drop system for building arbitrary robotic systems.
Yeah, like a GUI for just doing the config.
It definitely needs something. I mean, and I get why people like it, right? Once I've started to understand it a little bit, I'm like, wait, you're telling me I can just change a macro, hit a button, and I don't have to recompile? This isn't Marlin? My God, this is great. And now Marlin has gotten better, to be clear. Scotty, if you're high.
Marlin is sort of like at the limit of what Marlin can do. Like, Prusa spent many, many years polishing Marlin, but you can't get Marlin to do what Clipper can do. Like, Marlin's not going to run 14 MCUs in parallel and then allow you to do like Internet of Things functionality on top of it.
Marlin could. Prusa couldn't. Prusa was running the 8-bit boards on these machines, and yeah, they were getting every ounce they could out of it because they were running out of processor power. Marlin is not as easy to get it. Clipper was designed to just say, so, you want 15 motors. No problem. Marlin was like, you want more than 4? I mean, we can do it, but have fun.
Like, why?
You're going to need a bigger MCU.
Yeah.
I've been trying to get Scotty on the podcast, and we've just kind of never been able to link up properly. He's one of the main contributors to Marlin, and I think he's like the Marlin guy. Because I know there's been some contention between the Marlin and Clipper, and no one seems to really care about RepRap firmware, to kind of laugh at. But Marlin, Clipper, you know, people compare them, and he's like, it's not a fair comparison. I said, you're right, it's not a fair comparison, because we've never seen Marlin running on a Voron.
Mm-hmm. Yeah, they're different tools, and
we might have lost video.
Yeah, you
did. We lose?
But we have. Do we have audio still?
Yeah, your audio's still there. Oh,
all right.
Oh, you're completely gone from the show. All right. Hey, it's just Grant now. It's just Grant. So,
are we back?
Oh, hey, they're back. All right. Well, I gotta go back. I had just changed it. There. Now we're back.
It's definitely worth saying that the Marlin people did a great service to the community, and they deserve our undying
this
loyalty.
Community wouldn't exist without Marlin.
Yeah, definitely. And same with Prusa, but like we've advanced past the point where like Marlin is the tool that we would want. Like we love Clipper. It does everything we want it to do and more, and it gives us tons of room to grow into. Like if we were using Marlin, we'd already be at the limit of what Marlin can do, but we're at the very beginning of what Clipper can do.
And I think something specific about Marlin is like I'm not a programmer. I am, I'm not the most adept at that type of thing. I can't go into Marlin and make modifications and really understand exactly what I'm doing, but I can still do that in Clipper. Like it's simple enough to go in and write those macros and add those axes and motors and whatever.
And you can do a really fast revision. Like it takes 2 minutes to restart Clipper. It takes 20 seconds to restart Clipper.
Yeah, like, oh, I made that mistake. Okay. Oh, I know what that is. Let me fix it.
Right. Versus it's like 10 minutes per rev for Marlin. So in an hour, you can only make a couple changes.
Yeah, the traceability of what's changing it's very obtuse in Marlin, in my experience.
Yeah, I think that.
The whole recompiling thing's a pain in the ass, straight up.
Yeah, I think that there's a possible future in which Clipper could evolve into a general use robotics firmware.
Yeah, definitely.
We'll see, because like, I guess that has to depend on how the community does it. And that's the great thing about open source, man. You figure out a system that works for you, you publish it, someone else works on it, they update it, and it becomes a great community. The closed source has its place, right? Closed source, like there's no value in open source above like 50 grand. Because at a $50,000 price point, I don't want open source. I want closed source because I want that ecosystem where I buy my material, I'm paying an arm and a leg for it, but I have a guarantee that it's going to work.
Like an iPhone.
Exactly.
Like exactly. Right. Yeah. But even Apple understands that we're just going to go ahead and make the phone. We're going to make the AirPods. We're going to make the main accessories. We're not going to make cases. We're not going to make screen protectors. We're not going to make any of that. We're going to allow a licensure to exist with third-party manufacturers because that makes more sense in the grand scheme of things.
Mm-hmm. It's important to not let your company get distracted. You develop the key technology that makes people's lives easier, and then everything after that, maybe you do open those licenses.
Yeah, and there's also a big difference between hardware and software in focus. Like if you're a hardware company, you have to have a laser focus on what you're making and what you want to do, because it takes years to do development and it takes years to do logistics.
That it does. Beta Wire 4. Let's take a look at this. Oh, and then they're gone.
No, wait.
Oh, wait, they're back. All right, they're back.
As soon as we were like, oh, maybe we could do Beta Wire demo, it's like, yeah, no.
Yeah, so is this the best view for the CAD out of curiosity? Because I have various, here's a shaded version. Is that easier to see or harder to see?
I think the shaded version is easier to see personally.
Okay, good. So this is Rev A of the Beta Wire, and this has a funny story behind it. We actually never intended to really do a kit. I just wanted to make a fun YouTube video about wire EDM. So I designed and built this like whole machine over 4 weeks leading up to ARMERF. And then like the 2-3 days before ARMERF, I got it running. And then we did like maybe 16 to 20 hours of like demos during ARMERF.
Yeah.
But the what we're going to be shipping out in September is going to be Rev B of this machine. So we're going to make a ton of improvements to improve precision and quality of life. But I'd like to just run through what's neat about this machine. It's actually 2 Core XY systems stacked on top of each other.
Okay.
So here's let me isolate the top gantry. this is the top gantry. So this is the first Core XY system, and it's driven by these two motors on the side. And so there's belts and pulleys. I'm sure everybody's familiar with how a Core XY system works. And then there is a second Core XY system below, down here, and they're connected with just some stainless steel rods. And the advantage of this is that you don't need waterproof motors to run this machine. It just runs regular, like, LDO, NEMA 17 stepper motors.
But I guess because it's not, you're basically oxidizing the steel instantly. You're not going to make the water conductive, so the brushless motors probably don't care, right?
Well, the motors aren't in the water at all.
They're not in the water. Okay, well then none of this matters. Got it.
Yeah, no, so it's funny you bring up like waterproof brushless motors, because the next revision of this machine is mostly going to be to the tool heads. So there's a top and a bottom tool head. I'll isolate those. And missed it. There we go.
Ah, Fusion. Oh, the little freaking wire in there. It's so
yeah. I'm very fastidious about my CAD. I try and include literally everything.
Makes sense.
So there's a top and a bottom tool head. The top tool head rides on the top gantry.
Yeah.
The bottom tool head rides on the bottom gantry, and the wire is pulled in between them. So most of the revisions between now and release are going to be to the tool heads, and specifically we're aiming for closed loop tension and velocity control. And we're going to be doing that with probably waterproof motors, one on the bottom tool head for controlling velocity, and then one on the top tool head for controlling tension.
We've actually been testing our motors in a bath of dirty EDM water for like a week now.
Yeah, so we're working with a bunch of suppliers to get IP68 motors for this project.
Yeah, just to be safe, right? Like, allow it to get wet. You don't want it to, but if it does, it's not going to destroy everything, right?
It's a much better constraint to use the correct material that is tolerant to the environment that it's in than to try to protect the improper material.
Right. So
Totally
we aren't getting rid of these NEMA 17 stepper motors. We're still using the NEMA 17 stepper motors for like the X and Y UV axis control. Like the Core XY system will still use stepper motors. It's the tool heads that are going to be getting the waterproof brushless motors.
Got it. Okay.
Yeah, so this entire machine is designed to fit into a 10-gallon aquarium from Walmart. So we aren't supplying the aquarium. It's literally cheaper for you to go out and buy a generic 10-gallon aquarium than for us to ship you a gigantic glass box.
We're trying to get that Walmart sponsorship. So we use Walmart aquariums. We use Walmart great value brands, distilled water.
Yeah, so and then there's a vise here for holding the work.
Okay.
So that's where you can. This is a high-end wire EDM vise made of stainless steel. I should note that all the fasteners on this are also stainless steel.
It has to.
And
yeah,
it has to be. And the linear rods are stainless steel, and then the bearings are IGUS waterproof resistant material that's designed to go for like from here to the moon and back underwater.
That's like the perfect use case for iGoose over. That's like we have a Lulzbot Taz 6 for some reason, still. And it's got the iGoose, and I hate it because it's got so much tolerance. But in this scenario, it's perfect because a regular ball bearing system would seize up in weeks.
Yep. And so we're going to be working with iGuess to possibly even improve what we have now. So we might do some custom flange bearings. We might do some like custom rails. We'll see.
That's cool.
And then we're working with LDO motors for the actual kit. So you'll be able to get your Voron, your Milo mill, and your beta wire EDM machine from LDO motors, which is like, I don't think anyone was expecting there to be like a whole ecosystem of sort of open source tools, and it's sort of slowly keep creeping forward in capability.
Well, and I think there's a lot of value in working with an LDO or, some similar company because they make it easier to do this kind of thing where they're going to handle a lot of the sourcing and and all of that for you guys. They're going to help build the kit. And that way I can just go to any of their resellers and say, I want to build a Beta Wire 4. I don't have to go through the effort of self-sourcing it and potentially saying, I got my own guy that does stainless. My own guy that does stainless, right?
And the thing is that brings a whole lot more, again, it goes back to being able to replicate your results. So if everyone's building the same tier of machine with a known quality of inputs, they're going to be able to troubleshoot with each other much more readily.
Yeah, and people have started asking us like, oh, could I put like a rotary axis in here? What about like an automatic clamp so I could have like a robot arm that just reaches in, pulls out the part, and then puts in a new piece of stock? And yeah, I'd love to see that sort of stuff in the future.
I would not like to see a rotary axis on this machine.
We
we don't want rotary.
Well, here's the thing, like,
oh, so is that one of those like tell them the exact opposite and they'll do it things? Okay,
there is more.
This is such a fun game.
Okay, so we've already explained that there are no American-owned like wire EDM. As far as we know, there are no American-owned wire EDM companies in the United States that manufacture wire EDM machines. But the United States does have laws preventing the export of certain types of wire EDM machines. So we don't make them, but we do make it illegal to sell them to some people.
Right.
Which don't know why. That seems really silly to me.
Other nations selling them.
Yeah, China. We cannot sell rotary wire EDM machines to China, but China can sell rotary wire EDM machines to us. Great for China, bad for us.
Yeah.
Capitalism.
That's just good.
It's not capitalism. If it's not capitalism,
I know that's the joke.
To whoever I want. It's the worst. It's weird government regulation.
I, for one, have no intention of, not complying with the important rules that are set because they're there for our safety. So we're going to comply.
Yeah, we will comply, but we can't sell you a 5-axis rotary wire EDM machine on Amazon.
But I mean, like, if there's an open source build, sorry.
And yeah, that's that's where you have to make sure that you're complying. So I'm fairly certain the rotary wire EDM is an ITAR thing. Yeah, and so
on page 47 of the what your
CFR,
you have to register for shipping and whatever.
Oh, the EAR, the Export Administration Rules or something.
Yeah. And so that's where Defense Distributed decided to not listen, and you see what happened. So if for some reason 3-letter organizations tell you to do things, I highly recommend, and this goes for anybody, if a 3-letter organization tells you to do something, just do it. If they're wrong, sue them in court. Don't tell them no. But it's also why my general goal in life...
You never want to be like the name on the Supreme Court hearing. You just want to know that it went your way.
Yeah, it's why I say, what is my goal in life? I want to avoid 3-letter organizations as much as humanly possible. That is what I want to do, and I think that that's a very fair thing in life, right? But yeah, ITAR is something that a lot of people in this industry don't get, and I know that because YouTube comments. But
yes,
it is.
It is one of those things where it's a $250,000. What?
Everybody gets these weird emails from people requesting certain parts get shipped overseas. Like, hey, can you make me this? And it's me like, no, of course not. I'm not doing that.
We get them all the time.
Responding.
It would be supremely funny though if America's only like domestic wire EDM company was shut down for like weird ITAR reasons. That would be hilarious.
It would be funny for sure.
Yeah, open source is an interesting one here because I don't know. Since you're not hosting the files, I don't think it's going to be a. I don't think ITAR is involved.
It's not our design.
Like we're not going to put design for a 5-axis machine. We're not going to do any of the work. At what point, like if somebody posts it anonymously, quote anonymously, like on GitHub, it's like. Okay.
I can't control that.
Yep, you can't. You literally can't. Now, GitHub could take it down and all that, but it's GitHub. They're probably not.
I would say our official stance is we definitely recommend you don't do that.
Yeah,
you should comply with all.
Yeah, that's the line.
It is also worth noting, like I do wonder where open source technology is heading, because if it continues to advance, like we get to the point where like you could build like maybe a nuke at home. In 100 years, something like that.
You can already build a fusion reactor at home. We've been able to do those for decades.
Yeah. I know people who've built stars and jars. It's not tough. Like
Farnsworth
I know people who
makes fusers.
Yeah. I have a friend who makes his own deuterium fuel for his own fusion reactor that he has in his parents' basement.
Yes, and to be clear, those that are like, what? It's not the type of fusion that you're thinking of. Okay,
it's not a deuterium thermonuclear weapon.
Yeah,
it's
they glow. They put off an ass load of radiation, and they look really cool. That's really it. They don't. It's not cold fusion or anything like that.
If you put that you built your own fuser on your college application, you're golden.
Yeah, and they're really not that hard to build. If you ever have, part of me wants to do a whole video series where we build it and we use 3D printing to do it, but I have no practical application of owning a Farnsworth Hirsch Meeks fuser. I just don't. I don't think a lot of people that own them have a practical application of owning one.
No, they're just.
It's just because you can.
Cool. Yeah. Just like building your own five-axis wire EDM machine. I mean, you could do it if you really want to.
Well, and you could look at a 5-axis in a different, instead of a rotary, it's, so I've got a buddy with a flying 5, where Z, A, and C are all attached to the X-axis. There's not a rotary on it. It's effectively a 5-axis robot arm. Yeah.
We have people who have put the power core onto industrial robotic arms for like experimenting with machining carbon fiber.
Yep.
Oh, that's right. It can machine because you can EDM carbon fiber.
Yeah, you can.
Sort of.
It's weird because the carbon content is of course conductive, but the epoxy that holds it all together isn't. So your feed rate is substantially slower because you have to find a way to vaporize that plastic very slowly.
So continuing with that. So I used to actually build carbon fiber tail rotor blades for Blackhawks. And I think the resin component is only about 30 to 40% total. So your majority material is going to be electrically conductive. And even like when you're trying to machine through something that has a non-conductive coating on it, if you crash into it, you're going to be using the wire to abrade away that non-conductive material slightly.
So I need to use a diamond wire so that I can also then make it as a bandsaw.
I've designed. I was thinking about this the other day.
Bandsaw EDM.
There's an open source project for a genetically modified spider silk that's modular, so you can change its properties, and it's grown in bacteria and yeast. So you can like make kilograms of GMO spider silk of your own design in your garage if you know how to do the biotech.
Sir, I want my spider silk to be GMO free. Okay, get over this.
Sorry.
You all are in Colorado Springs. All right, that's.
What you can do, there are various types of spider silk modifications that have improved. You can do graphene coated spider silk. You can do nanotube coated spider silk. You can do mineralized spider silk. You can do metallized spider silk. So you could do a spider silk core that's as tough as steel with a conductive spider silk exterior, and then you could make that on a bioreactor, and you could turn sugar into EDM wire.
That is well beyond my pay grade, but I you know what? I would try it. What the hell? I mean, so all right, worst case scenario, it doesn't work. The wire breaks, right? That's it.
Yes.
Right. There's no other problem here.
Right.
Yes, the machine does not care. You could break the wire like 1 billion times, and the machine's gonna be like, "Oh, that sucks."
And you could even break the wire just through physical means, not even overheating it with electricity. Like you just snap it by crashing, and it's totally.
And that's what I figure would happen, right? If it's not as conductive as you need it to be, it'll either melt from current, or it's gonna crash and snap. God,
so
that's freaking
one of the
cool.
really cool things. One of the really cool things that the power core does is it reports essentially if your tool is about to crash. So there's a digital output on the power core. It's called the alert port, and it just has a PWM channel. And when no cutting is happening, the duty cycle is 0. And when your wire is about to crash into your work and the power supply is being overwhelmed, then it sets the duty cycle to 100%. And if you're generally when you're cutting, you want to aim for about an 80% duty cycle on your output, so you can use that for closed loop feed rate control. So like Clipper can look at that PWM channel, see that it's either too far away or too close to the work, and then adjust the feed rate.
Is that using like a load cell? Like how are you determining that? Is it measuring?
It's all solid state.
It's based on spark frequency, right?
Here's how it works. The power core outputs it has the ability to output a pulse like every certain amount of time.
Right.
And then it checks to see if that pulse actually did any cutting. So like I opened up the MOSFET, I was going to let the capacitors drain. It can check to see if the capacitors actually drained. And so it does this in a batch of 512 sparks. So if all 512 sparks that could have gone into the work did go into the work, you're at 100% duty cycle. You're way too close to the thing you're trying to cut. And if let's say you're far away, your electrodes are too far away, there's no cutting, none of those sparks will happen. Your duty cycle will be 0. 0 out of 512 of the possible sparks did not initiate.
Got it.
So
okay.
It's just comparing the ratio of how many sparks could I put into the work versus how many sparks actually got put into the work. And that's handled by the onboard microcontroller in the power core.
That's so freaking cool. So
that's it. EDM control. If you look at like the industry,
oh my gosh.
Yeah, so
they would say, are using like servos and stuff that have that full closed loop as well.
Oh,
yeah,
sure.
Yeah. Their kinematics are going to be more advanced, but the actual power supply technology, we're getting close to what is the state of the art.
Yeah,
I'm not going to say we're there yet, but we're definitely getting close.
Well, if like an investor were to come up to us tomorrow and say like, here's like $3 million, we could do enterprise machines.
Are you actively seeking funding at this point?
Yes. Please give us money.
Contact at rackrobotics.
If you are a venture capital firm and you want to be in our what are we, pre-seed?
I think so.
Yeah, if you want to be in our pre-seed
terms.
Yeah, if you want to be in a pre-seed and sign some safes, then we're accepting new investors. You can email us at either contact@rackrobo.io or investment@rackrobo.io. We're also taking angel checks north of like 250 grand.
And so for those who don't understand VC versus angel and all of that, there's a certification process to become like VC, to become an angel. If you don't know it, you probably don't qualify. Sorry.
If you don't have a portfolio of many millions of dollars worth of companies, then we're probably beyond that type of investor. Some of our actual first investors were people who like had never invested in a company before, like friends and family who gave us a couple $1,000s. Like Nick was our first investor. Yeah. He gave us our first $10,000 to start the company, and that literally paid the heating bill and got us going.
Yeah.
Hey, sometimes you got to pull yourself up by your bootstraps, right? And then other times you're going to go and ask for money. But yeah. I get it. I totally get it. Underhill says, are you sure you can handle the regulatory issues for a high voltage device like this? Underhill wasn't listening the whole time, clearly. Why don't we go ahead and explain that one more time?
Number one, don't touch the parts that are high voltage. That's the number one thing.
It's not high voltage.
And so like in terms of danger, it's significantly less dangerous than a CNC mill.
Also, the power core has an enable feature, right? Mm-hmm. So like if I was a parent and I was super worried about my kids screwing up, you can just put an inline switch with like a door. I mean, in the aquarium, maybe a door doesn't make so much sense.
But like on a consumer wire EDM or like an enterprise wire EDM we make, you can do like a door lockout.
Yeah.
And then the power core literally just won't power on.
Yeah.
So you won't even be able to hurt yourself if you put just something simple like a door in.
And just first principles, it's less dangerous than a CNC mill, because a CNC mill will physically harm you if you touch it. It'll rip your hand off. It can crush bones.
You're not going to get pulled into the machine.
Right.
John and I have both accidentally and on purpose connected our hands into the circuit previously, and it's definitely uncomfortable when
it tingles. Yeah. It's actually, I think the pulses are significantly shorter than a taser, but it's nowhere near the power of a taser.
Right.
Basically, they're not running high enough voltage that there is regulatory issues. There you go. That's the answer that we need.
Well, there are
always, all electrical systems should be beholden to electrical standards, and
but not the high voltage ones they're thinking of.
Yeah, it's not
480.
It's not 480. No, not 120.
Anything over 48 volts is considered high voltage,
right.
And when that occurs, you need to take proper precautions to not harm yourself.
So we're at 65 volts. Your 3D printer probably runs at like 48 volts. So we're just a little bit higher than that.
Oh, I wonder, is that why 3D printers have gone to 48 volts? Is because anything higher than it becomes a regulatory disaster?
48 volts is considered high voltage.
Oh, okay. Damn.
And it's worth
consumer
saying
ones are like 24 volts.
Yeah, and it's worth that the reason that we're moving towards 48 volts is actually because it's safer. Because if you're trying to transmit power, you can transmit it in the current phase or the voltage phase. The current phase heats stuff up.
Yep, you
The
need thicker
voltage
wires.
phase does not. So it's actually probably safer to build a 48 volt system than like a 12 volt system because you have less energy going through the current phase.
Yeah, it is much safer. And actually that's why the electricity here in the States that goes to your home up on the lines is normally like 13,700 volts, somewhere in that range. They use the pole pigs or the transformers that look like pigs. They have the tails. Anyways, to go down to 240, and then it's a split phase. So it's a center common with 120 and negative 120. Your house will split those phases up, and you get two separate 120 phases. That's how it works.
Yeah.
For
Sometimes
homes.
you get weight, right?
Yeah, so this isn't high voltage in terms of like what comes out of your wall. Nowhere near it. This is actually lower power than like a typical 3D printer heated bed.
Yeah. Well, I will say, like, the DC beds are normally like 200 watts maybe. The AC beds, I have a Magneto X with 1,000 watt AC heated bed. And I went into Cooper and put its PWM cycle to 50-something%, because I don't care. I don't need it to heat up that fast.
Right.
Yeah, so like in terms of danger, the heated bed on a Voron is much higher voltage and much more dangerous than the power core.
Yeah.
Well, that, and if you touch the heated bed when it's hot,
It'll burn you.
Right.
like,
So Underhill continues saying milliamps can be lethal if conductive. We're going to get into that in just a second. I only asked any of this because regulatory and product requirements in the US. So these guys are US based. They are selling in the US. They have funding, so they are required to understand this. So they're not selling you a death item. But to be clear, your skin is not very conductive. It is milliamps across the heart to do it.
If you were to attach the power core to electrodes and then plunge those directly into your heart, so that it was conducting the entire load across the muscles of your heart, you might have a problem then.
That would be not compatible with life, but a 9 volt would also not be compatible with life. So
yes. And
well, like you have I guarantee the computer that you're running on right now, the computer everyone's watching this on, has a bigger power supply than the power core is.
Yeah.
It
right. Like
definitely
we run
does.
8 power supplies, right? Like,
yeah. So the long and short
and literally the leads on your computer power supply look like the ones that come off of the power core.
Yep.
They're the same thing.
Yeah.
So the long and short of it is, don't make yourself part of the circuit, please. Take precautions, and it's all quite DIY still. So you need to understand how to not make yourself part of the circuit if you're going to be using that type of thing.
Yeah, and I'll simplify it. Don't be stupid. Right? If you don't know what you're doing, don't do it.
It is a tool. It is a machine tool, and it's safer than like a chop saw, but it's still a tool that you should be cautious around.
Like, would you go grab your hot end mid-print? Don't be dumb.
I won't say I've ever done that before, but I've definitely burned myself many times on hot ends.
Sure. Yeah,
but that's because you get comfortable with the thing and you're like, oh, this is fine, but it's not, right? Like and people do that in machine shops all the time, and then you get a live leak video.
Yeah.
But like,
people remove safety barriers, they bypass safety stops. There's all sorts of stuff that people will do to try to get some out of it, and then they harm themselves.
And then that's why the power core has an enable port. If you plug in the power core, nothing will happen. You have to actively tell the power core, I am ready to output high voltage at this moment.
Yep.
Yeah, I mean, like that seems like as much of a safety precaution as anything else that we could possibly do.
Yeah, I don't think you guys are being reckless here, to be clear. I mean, certainly when you're showing that you can put your hands in the water and it's safe, that's a little reckless.
Don't do it.
But yeah, obviously, please don't be stupid. But, this is not high enough voltage to create issues unless you're trying to create issues. And at that point, F around and find out, I guess.
Take your car and drive it off a cliff. Like that's not the car's
let's not go ahead and suggest people do those things.
Don't drive your car off the cliff, but if you happen to drive your car down a steep incline and it doesn't survive, that's not the car
manufacturer. I live in Florida. We don't have cliffs.
A better comparison.
That's true.
A better comparison would be like a resin printer. Like resin printers are hazardous. You have to use the proper safety precautions when you're operating resin printer. You have gloves. You have to have ventilation because the resin is carcinogenic and it contains like tons of things that will give you cancer or physically burn you, like give you chemical burns, thermal burns. Use proper safety when you're using a resin printer. Likewise, if you're operating a CNC mill, use the basic safety guidelines that the manufacturer of the CNC machine recommends.
Yeah.
If it's moving and it's electrical, if it smells bad and it's liquid, don't touch it.
Yes.
Right. Yeah.
Not complicated.
No.
Yeah. You know, there are times where, yes, this is like your first revision was literally on an Ender, which I love. I love the fact that you made it to fit an Ender 3, because like, how could we make a motion platform that is as affordable as humanly possible? We use the world's most ubiquitous 3D printer that you can get for literally $100 brand new if you don't live in a bad state that, you know, has a micro center.
Right.
Screw you, Florida. We need one, and I need one closer than Miami. You're opening one in Miami. It's too far away still. Give me one in like Tampa.
The whole reason we actually went with the Ender is because we were literally too poor to do anything else. Like we didn't have the money to design a full motion system. We'd love to. Again,
but does it need it?
Raising our pre-seed round specifically to build a motion system for our like flagship product.
High quality turnkey wire EDM would be wonderful for the world.
It would be a game changer for the United States if every university student had access to wire EDM machining, because
And the same machine too.
Yeah.
Yep.
But so the Ender was largely an illustrative thing. Beyond just not being able to afford a superior machine, Ender, it was illustrative. A good portion of people in the 3D printing community with any familiarity with these machines will say, they'll make that connection and say, oh, it works on an Ender 3. If I have anything else that's better than this, maybe it'll work better. And that was largely the point of that as well. Saying,
And
like,
will
okay,
it like
functional worst thing there?
Can let's say you go from an Ender to a Voron, right? Same thing using and I know that's Core XY versus Cartesian.
People have stuck this onto an Ultimaker. There's a EDM Ultimaker conversion that somebody did with a power core.
Yeah.
And EDM, it's a little bit different than 3D printing. You're not going to be running crazy speeds. What type of speeds are we looking at traditionally? Again, pick your poison for metals, just let us know. But these aren't speed demons.
Yeah, that's a great question. How fast you can cut is proportional to two things mostly. One is how thick it is. Thicker materials cut slower. If you double the thickness of your material, you have the speed. And then two is melting point. So higher melting point materials cut slower. It's a thermal process.
Yeah.
Now, to give some example feed rates, if you're cutting 3mm aluminum, you can get up to, I think our fastest we've done is 28 millimeters per minute in 3mm thick aluminum. And so if you were to double that and you go to 6mm thick aluminum, then you'd be at 14 millimeters per minute, roughly.
Yeah.
Pulled out the calipers, like, how big is this
That's
thing?
28 millimeters for those that are wondering. That's
so you can cut
like, it's not
that
fast.
That will always be faster than waiting for shipping.
Yeah.
Oh, yeah, of course. It's not fast, but it's unattended. Walk away.
Yep.
Go get coffee, go drink a beer, watch YouTube. Do literally anything else.
Start the next one to do the same thing, and then the next one to do the same thing. And
well, it's like, how can we get this thing to cut 5 times faster? By 5.
Could I put multiples in one tank?
Like, I guess you could if you had a big enough tank. We talked about the kiddie pool wire EDM machine.
Yeah.
There's a 120-gallon fish tank sitting about 12 feet from me right now.
Are there fish in it?
Currently, yes, but that could be adjusted.
Oops, sorry.
I mean, we can rehome the fish. There are other tanks. That's no big deal.
Or you could do electric eels. I think they'll be fine.
They like.
Don't do that. Please.
So we have a contract with the EPA where we dump all of our excess power cores into the ocean to recharge electric eels.
That's true. The EPA actually is our main funder right now with that.
There are people that are going to take you guys seriously when you say that stuff, just so you're aware.
How do they think electric eels get charged up right now?
Yeah, it's actually a big crisis. Yeah,
I thought it was solar powered, right? They're darker. It's probably photovoltaics.
Well, we have an adopt an eel program. So for $10 million, you can adopt an eel, and we'll dump a power core into the Gulf of Mexico.
That's right. We will personally drive and heave it in.
Honestly, that'll be less pollution than a lot of the big companies out there right now. So
We're doing our
Well,
part.
you want to talk about pollution. Imagine like 5 kilowatts of electricity going towards giant hydraulic servos and heating and then cooling water.
Yeah, we heat up the water so we can cool down the water.
Yeah, the electricity bill on these EDM machines is enormous. Like you can spend 10 grand a month on EDM power if you're running an EDM shop.
Yeah, and that's a shop with only like 6 to 8.
Yeah.
yeah, that's but now those larger machines, what type of speeds are they running?
It depends on what you're
Yeah, it
cutting.
depends on the
That's
machine, and there's various types of machines. There are some machines that are optimized for just speed, and they'll use special wire to do that.
Most machines, though, you'll see like GF has some new algorithms that they put out for doing finish passes, and running finish passes is usually going to be faster than your roughing passes, but your roughing passes are always just going to be limited because you have the channel for flushing that waterway is so limited.
Yeah.
Right.
Like everyone has that exact same physical limitation of I need to push water through a path that's literally 0.1 millimeters wide.
And that's just physics. You can't really get around that.
Like you could have the highest power supply you want, but like
You still got to flush water, and that's actually the limit we found on a lot of our implementations. Isn't the power core? Like we're running the power core at a fraction of what it could output. Like you if you really wanted to, you could change some firmware settings, and you could do like 15 kilohertz instead of 2 kilohertz, and you could cut faster. But you need to have a lot more water going through the gap to clear away chips.
Yeah.
So I mean, if you like, go get a pressure washer if you want, I guess. Yeah. But like at some point, it's genuinely just going to be like the water does not want to. Like I mean, if you think the nozzle has to sit above the workpiece, the water does not want to go through the very narrow channel when it can just spread out over the top of the material.
Yeah, you need like a laminar flow nozzle that's very, very well directed. Like, and do you need a water tank? As AZA built to code says, is a water tank required, or could you just mist or a water jet?
Not.
Okay, the rabbit hole did first more.
Okay.
So there are EDM machine designs that don't use water, but they use like 3 kilovolts for the discharge. So
because your air becomes your dielectric.
Right. So instead of your RepRap being like microscopic, it's literally macroscopic. Like you see a lightning bolt shoot out like an inch.
Yeah.
And in that case, you don't need water. The air will do it.
And some machines will actually just dribble water down coaxially with the wire. And those are a specific kind of high-speed wire EDM machine where they're running wire like at a meter plus per minute through that, or I think it's a meter plus per second. And it's a special steel core moly-coated wire.
That's pretty cool.
Whipping through there, and it's pulling the water and waste through and out of the gap by going so quickly.
And there's also some academic papers on using water mist instead of just water. So it's like mist EDM or compressed air EDM. But for our power supply, you want to use water.
For your own safety, you should be trying to use water.
Yeah.
You don't want to get a big tank of kerosene spilled on the floor.
So a lot of EDM machines won't use water, they'll use oils, and they have to have fire suppression systems on the EDM machines to keep the oils from catching fire.
Yeah. Because it's a
big
big
real good.
Plasma.
I'm real good. I don't want to do that.
Right.
It's weird because like, so GF is a huge player in the EDM systems, and they use water. But like Mitsubishi is recently making a move toward oil in their wire machine, like much more commonly. Oil is really common in sinker EDM, not as common in wire, but
because you don't have to, it's easier to recycle oil than it is to recycle water because the oil will not react with the metal. Yeah. So we talked earlier about how the metal powder gets oxidized by the water, but that doesn't happen in oil. Oil protects it. Like you could cut sodium with wire EDM under oil.
Yeah. So like when you're using water, you slowly will increase the conductivity of the water, and that's going to change the parameters of your EDM setup. For our purposes, that's not a huge problem. A large volume of water and a relatively small volume of metal machined.
And we aren't aiming for that 1 micron precision. If you want to hit 1 micron tolerances, your water has to be ultra pure for all time. Ultra pure. Yeah. For all time. You can't use dirty water if you want to hit a 1 micron tolerance, but if you're going plus or minus 50, not a big deal if your water is a little conductive.
Yeah.
So what about like a mineral oil? So Mad Cat USA is asking that. What about mineral oil? Is that possible? Because people have been submerging PCs in mineral oil for a while because it's a dielectric. It doesn't conduct.
I imagine it's possible.
It's
We've never
certainly
tried
possible.
it. It's more viscous than water, and that makes flushing more difficult.
Right.
So,
So,
like,
we recommend water just for your own safety.
Yeah. So imagine.
Really? I figured viscosity would help because that would keep the flow more directed.
Nope. Imagine trying to suck it through a straw.
Like,
Like,
have this boundary condition is what would be called in
Yeah.
on the walls. The water is literally like in a textbook. It will tell you like the very, very first layer of like atoms basically are stuck. So the more viscous it is, the bigger that curve is going to be. So you really want something super low viscosity. If you look at the equations that tell you how much drag a pipe has, fluid viscosity is on the top. So as you increase viscosity, the drag in that pipe is actually going to go down.
so you have to imagine this wire is cutting through your material, and there's like, I don't know, 70 microns on one side of the wire of clearance, and then 70 microns on the other side of the wire of clearance. So your whole channel that you're trying to flush water through might be only like 1/3 of a millimeter to 1/2 millimeter in diameter. It's a really, really thin straw.
Yeah.
So imagine trying to suck up a really viscous oil through a thin straw. That's much more difficult than trying to suck up like water through a thin straw.
It's your milkshake. Like, go drink a milkshake.
Yeah.
Well, I mean, for science, I guess I'm gonna have to show this on a video.
Well,
Right.
we had one night where we ran out of distilled water
Yes.
at like a year ago.
Yeah.
When we first started the company, we ran out of distilled water and all the stores were closed. So like we ran out to the drugstore and we tried using isopropanol.
And it does work.
Yeah,
It's
I don't recommend it.
No.
So we played around with that. But then the other thing we did is we grabbed snow from the backyard.
because
And
we were in Michigan.
yeah, in the middle of winter. So we just melted snow and poured that into the EDM machine and it worked.
I guess that works too. Yeah. We see WD-40. We're seeing some, you know.
Yeah.
WD-40 actually works. That's an industry standard on some.
Oh,
punch
really?
machines. Yeah.
Yeah, Ben Fleming is someone that we looked at when we were first doing our initial research on the PowerCore V1. Had a bit of correspondence with him. He did his own DIY pulse EDM, and we actually have his book.
Yeah, he
here.
wrote a book called Building a Pulse EDM Power Supply. You know, there actually is almost nothing in common with our design from his design. We use different electronics, but if you want to like go buy this book, I'd recommend it. It's a good read.
Yeah, give Ben Fleming the money.
Yeah. And then we also have a couple wire EDM books. There isn't a lot of literature on wire EDM, unfortunately.
So the point is, Ben Fleming he's used gallons of WD-40. He's used kerosene or diesel. Any like hydrocarbons are going to be very consistent dielectrics.
Right.
It just depends on what you're working with, and
they could catch fire.
yeah, or explode.
And it's also going to change your spark gap parameters.
Yes.
Exactly.
Yes. So
You're going to have to modify the firmware. Like if you
You
don't
have to
use
tune.
water, you're going to have to play with the firmware.
yeah. So the dielectric breakdown distance for water is about 1 volt per micron. So we run at 65 volts, which means that the spark is about 65 microns long. And if you have a dielectric that's twice the strength of water, then it'll be half of that distance.
That's just cool, man. Like, this is it. It's things that I don't think about, you know? Like, I don't think about dielectric distances and viscosities and, oh, you know, you could use gasoline for it, but, you know, that whole problem of we're making sparks under the gasoline and
Like don't smoke at the gas pump, but go ahead and throw a wire EDM machine in there.
well, okay, to be fair, right? It's not the gas that's flammable; it's the fumes.
Yeah, exactly.
Yes,
the vapors.
yes. Yeah,
Like
the
you're going
vapors.
in the gap.
Fun chemistry fact: liquids and solids are inflammable. You cannot burn a solid and you cannot burn a liquid. Whenever you see something that's solid on fire or a liquid on fire, it's actually the layer of gas slightly above it. Because like the way the molecules cannot thoroughly mix with the air, they cannot get close enough to the air for a solid or a liquid to combust. It has to be in the gaseous phase.
There's gonna be like someone actually in the comments,
Right.
but I can't think of anything to refute that.
Okay, yeah, but I am fallible. I'm sure I've made a mistake in this video.
Sure.
I
I mean,
mean,
We've all said no oxygen, no oxidation.
right.
Yeah.
I mean, I guess unless you had like something really
Well,
crazy like
I mean,
fluorine.
You want to
Like,
use
so
a
do you-
fluorine
Yeah,
dielectric?
unless like you're like
Liquid fluorine dielectric.
I thought it'd be really fun to play around with like acetone or a dichloromethane, like
So-
an extremely thin liquid.
Do
Okay,
not
so-
play around with
don't.
dichloromethane.
Don't do that. It will give you cancer. But if I had like if I could pause time for 4 months, this is a phrase I'm going to steal from Stefan at Populo. He says this. If I could pause time for 4 months, I would love to work on an acetone wire EDM machine, because acetone has it's so thin, it has very low viscosity. So you could get some great you could get some really, really nice flushing with it.
And it'd be a really consistent dielectric too.
Yeah, it'd be nice.
That's
just about.
But one like
it'd form a layer of gas as shield gas. Yeah.
The thing I really like about
patent that. Take off the podcast. Shut it down.
We're patenting stuff now. Yeah, we've immediately skipped it from like everything open.
It's over.
I mean, look, the money's not an open source. I'm sorry.
I gotta eat. No, but the thing I really, really like about water as a dielectric is that millivolt to
1 volt to micron.
1 volt to micron like comparison there, that ratio. It's so digital, it's so easy to do that math, and it makes EDM just way easier to actually for Nick to make the software for. Like, it's just so cool to me that it's such a discrete process. Like, you've got one spark, it's removing, this amount of energy of material, like whatever that translates to, vaporizing. And you've got that discrete distance a spark can reach out in perfect water. It's so cool to me.
Yeah, so I mentioned that the power core, the way it's set up is it outputs energy for 32 microseconds and then it pauses for 512 microseconds. The reason it pauses for 512 microseconds is to leave time for more water to get into the spark gap.
Yeah,
it's literally to just refill it so you're not trying to use air as a dielectric.
Yeah.
Or it wouldn't be air, it's a vacuum.
It would be, cavitation. You form, again, wire EDM is not exactly well understood. There are papers that will break down the spark gap process into phase A, phase B, phase C. It does this, this, and this. But if you dig deeper, there'll be papers that say, well, actually, we really don't know exactly how this works. It's unknown currently if the material removal process is powered by metal vapor pushing the liquefied metal out of what you're machining, or if it's some Lorentz force thing where the extremely high magnetic fields force material part in at the spark gap. It's sort of unknown.
So what you're saying is we need the slow-mo guys to get one of your machines and put it to 800,000 frames a second.
Yeah. And it's not just a challenge of can I get good slow-mo of this? But if you're just doing surface cutting, it's almost a different regime or different paradigm than when you're doing that slotting kind of process.
Yeah, if I had to design an experiment, I'd get 2 tungsten spheres and very, very closely move them closer together with the slow-mo camera and just watch one spark happen between those 2 spheres.
And you could do that with flexures that you wire EDM.
Yeah, you could do a precision flexure to bring your spheres close together.
There's been a lot of comments regarding different chemicals. Nitric oxide has a viscosity of 19. C30H62 has a viscosity of 31. I guess that's squalene.
Squalene. So squalene is a really common oil in the biotech and microfluidics world. It's you can get it off Sigma Aldrich. It's a well-characterized hydrocarbon.
And then a sap coated wire or sap coated water. I don't know. Sap is capitalized, so I'm assuming that's a chemical, and they're not talking about tree sap. But I'm too stupid to know what that chemical is.
I've combined chemistry and machine tools in a lot of weird ways in the past. In the past, I had this problem where I had to keep resin, 3D printer resin, floating on top of a liquid for a specific engineering problem. It's very hard to find a liquid significantly denser than resin. So what I did was I found a rare earth salts. I think it was gadolinium chloride that is attracted to a magnetic field. So instead of finding a really dense liquid, a liquid that's more affected by gravity, I found a liquid that was affected by magnetic fields, and that created artificial density so that the resin would float on top of the sodium of the gadolinium chloride.
I still have the big magnets.
Yeah, this was many years ago. We bought some really gigantic rare earth magnets, and I have bags of rare earth salts.
How do they work? That's the real question. Oh, and apparently sap is a super absorbent polymer. Think diaper stuffing, and that is I forget what that stuff is called. But yeah, so you want to wire EDM with Orbeez. Okay. It's not impossible.
I honestly think there's going to be, like, in the future, the wire is going to advance and change a lot more than the dielectric.
Yeah.
Like in 100 years, we'll probably still be using water for EDM, but the brass will be like something weird, like diamond nanofilament or something weird like that.
Were we talking about there was
The superconducting EDM wire?
No, the aramid cord.
Yeah, like a copper coated, zinc coated Kevlar fiber, or I'd be interested in like carbon nanotubes with like a graphene coating. That would be great because graphene has extraordinarily high melting points. That'd be probably one of the best materials you could use for coating wire.
You'd be able to run the wire really slow.
Yeah, it'd be nice.
So is the issue then more in terms of like cutting speed and all of that wire based, or is it dielectric based? I understand it's a mix of the two, but which one is
just flushing? It's actually a flushing.
Just flushing, but wire. Okay. So, for example, the wire that we sell and the wire that we use is coated with zinc. Mm-hmm. Zinc is a special metal because it has a very low boiling point. So what happens is the wire, when it gets hit with a little lightning bolt, the zinc on the surface vaporizes and it forms a layer of protective gas, zinc gas, around the wire that protects it from heat.
Yeah. So it's like double boiling chocolate, but instead of using water for your double boiler, you're boiling off zinc instead for your
and then the zinc
sounds tasty to me.
Zinc mixes with water, and then it forms little zinc particles, and then that gets trapped in the water.
Yeah.
But a lot of commercial machines will actually run their wire really fast, so you can entrain water.
Yeah.
So you're literally dragging the water along with you, along with your wire.
Like we said with the steel core molybdenum meter per second.
Real fast.
It's on these two capstans going back and forth through the.
So you're not just electric, but it's also kind of a sawing effect as well, right? But it's an electric saw.
For those machines, yes, not ours.
Yes.
Not currently.
Now, was that decision just to keep the price cost down, or is it just easier to do it this way?
It's easier, and the wire is a lot cheaper, and it's much more common, so it's a better place to start.
Yeah.
Interesting. So this is the cool thing about having an open source project, because you can say, here, you want to mod it? Have at it.
Yeah.
Have fun.
But
post your results because we want to see.
Yeah. If somebody makes a tool changer, awesome. Throw it up on YouTube, tag us, send it to us on our Discord. Like, sweet.
Yeah. One of the things that we were discussing potentially would be like a bounty system for different stuff.
Yeah. Especially like that was one of the whole advantages of making the PowerCore open source, was that we can do a bounty system for improvements, and it's really easy to work with software developers because it's already public on GitHub. Patents are huge. Patents have the ability to actually impede your R&D process because it makes it more difficult to collaborate, and it makes it more difficult to find talent versus just publishing on GitHub. I think that there aren't a lot of places that patents make sense for us. Like if we have some weird novel technology for an enterprise product that is only ever going to see like enterprise customers, maybe a patent is appropriate there. But for the PowerCore, it's not appropriate at all.
Makes sense. I mean, you guys are trying to hit a market that is, up until Bamboo, incredibly resistant to closed source applications and is very open and welcoming to open source because, well, we don't have to trust you. We can just verify it. There's no reason to trust you. Now, Bamboo has kind of started that shift. Of course, there have been other companies, but Bamboo was probably the first widely adopted consumer-ish grade 3D printer that is fully locked down.
Yeah. And that's the advantage that they pose there is the same as the iPhone. You don't have to care about the source of it because it just functions for
it's a tool.
It's a tool.
It's not a 3D printer as a community, it's a 3D printer as a tool that just prints.
It's a means to an end.
I guess the same way that now people's iPhones are undeleting photos, you should also be worried about your data when it comes to closed source systems. Not that I've talked about this in a myriad of reasons before.
Well, we just assume that everything we put on our Bamboo gets sent back to China.
Yep.
Safe assumption everybody should make.
Yep.
Yeah. Like run ours on LAN now. I think we have them disconnected.
Even then, there's still a degree. I don't trust it unless I desolder the Wi-Fi chip.
That's true. If you do that, it stops working.
Probably, yeah.
No, it does.
Oh, great.
Really?
Yeah.
That's great.
Maybe you can just cover it with a Faraday cage.
Yeah.
You can do that. We've seen people cut the wire for the antenna, which drastically reduces its Wi-Fi, but you're never going to stop it from logging. The trick is you're not stopping it from logging.
So as soon as it touches the net, it's just going to throw everything that it's having on.
Yeah,
I
we don't
can't
have
confirm or deny that I can't confirm or deny that specific thing. What I can confirm is that my machine, my specific Bamboo, was attempting to make multiple calls to a cloud server, and Bamboo says that it doesn't do that. I have proof inside of their log file that it was attempting to do that.
And we have no interest in doing that, even for like enterprise sales. Like we have customers who have talked to us about purchasing like enterprise solutions, and that was one thing they asked about. Like, hey, are you going to take our data? Is there like some sort of cloud bullshit? I'm not sure if I can say that word.
You already said it, so it doesn't matter.
I'm sorry.
You can cuss all you want. I don't care.
Yeah, there's cloud BS on a lot of these products. Like, no, we don't have any interest in that. We don't want to do that. I hate when products do that to me. Why would I do that to my customers?
Right. And that's part of the deal, right? Like at this point, like we're making some pretty hard decisions here. When it comes to working with companies, given who funds them and their data collection policies. And like that's been difficult because it means that we are significantly reducing the kind of companies that we want to work with. However, what it does do is it validates the fact that we do care about data, right? If our client data got out, we'd be sued. If I'm lucky, I avoid prison. We would absolutely be sued. And for the average user, that doesn't matter, right? The average user doesn't care. Now, that's a different discussion of what your data is worth, but I appreciate the fact that you guys say, no, we don't care. We would, if you want to provide it to us, by all means, we would love to know what you're doing and how you're doing it. But we're not even going to allow logging for what we do. If you want to log it, you can log it. And
I mean, like,
I appreciate that.
If somebody if somebody figures out, oh, hey, your steel parameters actually kind of suck.
Yeah.
Here, use this instead. Sweet. Tell it to me. I'm going to run it on our machines for a couple of days and say, oh, yeah, cool. Like, we'll push that out as a new steel parameter.
Yeah. But credit to XYZ person.
And that's the huge value of open source. I mean, literally, I think it was last week. Was it last week? It was. We don't like the cooling solution for the Prusa XL. We don't find it to be adequate. Prusa has yet to release the in situ CAD model. That's got everything, right? Well, I've got expensive ass 3D scanners that will get 50 micron accuracy without even trying.
Right.
So I scanned it live on YouTube. That was my thing last week. We were just hanging out and scanning. So now our team has it, so we can not only design a fan duct that fits, but CFD optimize it based on everything that exists there. But like, and then what are we going to do? We're going to work with Prusa. If we can, release it directly to them so that they can implement it, they can verify it, and then we release it publicly. And if we're lucky, it becomes a stock component inside of the XL. And if we fail, we fail. But damn it, we're gonna stack the deck in our favor as much as we possibly can by using high-end equipment to do what is not reasonably a high-end thing, but smoke them if you got them, right?
Open source is great, but I think that it's very important not to bank on people buying your product just because it's open source. And I think that Prusa is having a lot of trouble with that now, because given the choice between like an open source printer or the X1C, which is like fully calibrated, works out of the box, prints fantastically, the market is choosing the X1C over the Mark IV.
It's a shame. I don't disagree with you. It's a shame. But I mean, that also shows the the commodity movement of this industry, where it is trying to get into the homes of individuals. But you know, and we've said this, and I think you guys will understand it as well. The biggest challenge of any company in this industry right now is educating the new users. It's educating the current users, and it's educating the future users. We have an education problem. Like, if you guys had an instruction manual and, you know, all these ways to determine, and you had a huge like wiki with videos and pictures and lots of text, then you wouldn't need all the users. The users are there because they're going to be helping as well. Right?
And that's why we're raising money. It's because we need to hire more people. We only have 3 people, and that's not a lot of man hours. Like, this is the whole company. So like, if we have more people, it means that we can hire engineers to do the engineering work, and then we focus on stuff like marketing and documentation.
And I think maybe even more valuable than documenting how to use a machine is to lower the skill floor for using the machine.
Right.
Remove the to understand the process in its entirety, remove the need to have to calibrate manually, like have the machine be able to handle that for the user, because the user, that's not the value proposition that they're looking at.
And that's one of the really cool things about wire EDM is that there's significantly less to learn than operating a regular CNC mill. Because when you operate a regular CNC mill, you need to know about like touching off tools. You need to know about the various varieties of tools and how they function.
And feeds.
If you just change the path on like how like the order in which your tool surfaces an object, it can change the tolerance. But with wire EDM, there aren't as many problems like that. Like what tools are there? There's a hole popper tool to drill a hole. There's a wire tool to cut a path. If you want to get fancy, you can also do EDM tapping. Like we have a couple of EDM taps.
Sure.
So you can like actually make a threaded hole with an EDM electrode. Like those are the three varieties of tools.
Super sick.
Yeah, if you want to tap hardened steel at home, now you can.
Yeah.
So wait, you mean I don't want to just break my Harbor Freight taps and hardened steel all the time?
But like they don't even tap accurately when they don't break.
Hey!
There's
Us home machinists, if I can't see it being a problem, then it's not a problem.
So there's a lot less going on than in a regular CNC mill, and because of that, to automate. Like there is a pathway towards a turnkey wire EDM machine. You just put in the stock material. You tell the machine what you want to cut out, and it takes care of everything. It'll pop the holes, it'll thread the wire, it'll make the part.
Yeah, the fact that it's all electrically conductive helps with that, because the machine easily, like for low cost, find out where stuff is, what stuff's made out of, how thick it is.
It can probe, it can compensate for the tilt of the wire just by doing a couple probe operations.
Yeah. And the beta wire can do all of this.
We're going for that on release.
We're working towards that.
Yeah, we're working for that. That's why we chose to delay kitting the project out by 3 months, because we want to add in more features and improve the quality of life for the user before release.
Yeah,
because we don't want to like release the first version of the beta wire and then like 6 months later do a second version.
Right. Yeah. That's it's always fun when companies make multiple iterations in their first year of production, so that when you buy spare parts, those spare parts don't fit your older machine. Like, I'm deliberately calling out Bamboo on that one.
Yeah. And while the beta is primarily 3D printed, so that helps alleviate some of those issues, but we don't want to, release it right now and then release it in 3 months from now and say like, okay, this second version, Rev B, is significantly better than Rev 1. Why'd you build this one?
Yeah, so the plan now is I'm going to throw Rev A. So the thing that's on my screen, I'm going to put this machine on GitHub as like the first revision. I'm going to put a warning like, hey, this isn't representative of what's being shipped because we're improving everything. But if you want to go and mess around with this CAD or like do a self-source build for this, go ahead. And then as I make revisions to this, Rev B for the actual kit, that's also probably going to be developed live on GitHub.
That's awesome. And see, like that's so valuable, because you're saying, all right, yeah, we don't have the money for crazy hardcore engineers, but we can put up what we have. Yes. Let the community of crazy hardcore engineers help us out where we need it, call us out where we need to be called out, and then we become better because of it for the greater good of all the customers.
And that's why we're raising money right now. Is we want to get a mechanical engineer, an electrical engineer, and potentially a software developer. Yeah. And that would significantly speed up our development, and it's going to allow us to sell a turnkey wire EDM machine to consumers and universities as soon as possible.
Yep.
That's super cool. And that is so valuable in this industry, to me at least, right? We've got a lot of when companies don't want to like open source when they're in the development stage, and a lot of them do this, right? A lot of them are guilty of this, where they will only open source once everything is out in the public. You guys are saying, well, Rev A, we're going to put it up now. If you want to mess with it, fine. But we would really we kind of need an idiot check to make sure that we're doing it right. And if we are, then let's see how we can make it better. That's awesome.
Yeah, and that's
one thing that's real. This is not to you. This is to everybody else. When you go to critique the Rev A, please do not talk about the gantry alignment. It is a problem to like.
All you should do is talk about the gantry alignment.
No, no.
I can't take it anymore. Stop. It's the easiest criticism to put out about the beta wire is like, okay, well, it's sitting in 3D prints. How could that possibly be like? Because you have to square 2 different
We're
gantries.
definitely aware of that.
But you can compensate with it with software.
Yes.
Because you have the UV axes.
Mm-hmm.
So like,
It's
I hear the complaint. I'm
We're
not
all here.
ignoring it,
Yeah.
but I'm telling you, it's legitimately way easier to solve that with software, and you give yourself flexibility on the assembly side for the user.
And
if we can just compensate with software,
so we're working with LVO Motors to do the kit for Rev B. And one of the things that opens up is like we get a lot more choices for customization because
Right.
LVO is going to be manufacturing. So I think that for the next revision of the gantry, we're going to go with like a full metal frame potentially.
Yeah.
Okay. All right. That would be, and like that would be nice, but God, that's going to be expensive.
No, not really. Do you know how cheap aluminum extrusions are these days?
You're going to use aluminum and not stainless.
So we're gonna use anodized aluminum for part of the frame, and then the motion is probably either going to be anodized aluminum or stainless steel. And they're you can get like a level 3 anodized, which prevents against corrosion.
Yeah, level 3 is it's a really thick coating. It's very consistent, and you can't EDM it by accident.
Yeah,
which is nice.
it's electrically conductive, so you don't have to worry about anaodic corrosion, and it's
Non-conductive.
it's electrically non-conductive.
Yeah.
Yeah. So the level 3 is electrically non-conductive, so you don't have to worry about anaodic corrosion when it's in contact with steel, and you also don't have to worry about just chemical corrosion when it's in contact with water.
And
So
if
we're
I do
probably
something
gonna have-
stupid, I'm not going to cut through it.
yes,
So we're probably going to have like an aluminum frame with stainless steel rods for motion.
Okay. Yeah. I mean, some issues potentially with galvanic corrosion, but I mean that
Oh, that's what-
Adelrin bushing solves that too. So
yeah, exactly.
Exactly.
Like,
Yeah.
just puts literally anything between them that's
Mhm.
not going to facilitate.
Right.
yeah,
Like, think if you know that problem exists and it still happens, like that's just dumb.
Yeah, these are basic engineering problems that can be overcome.
Working with water and metal is our speciality.
Yeah, so
Yeah.
Watermelon-
we actually like I have a whole catalog of materials in my head that I've like mentally like said, okay, this is safe to put on the beta wire.
Yep.
Like Teflon, Delrin, PBT, like plastics that don't absorb water. Like 304 stainless steel is fine in distilled water. The fasteners are A2 stainless steel, which are fine in distilled water.
just do
Yeah.
H2 everything.
Yeah.
That's hard in
H2.
it's hard in tool steel.
Oh God, oh God, no.
Nightmare.
Can you imagine like if you were to actually build a wire EDM machine out of like a monolithic block, like get a gigantic block of hard
Dive
steel.
plunge it.
Yeah, that'd be fun.
I would love to see a monolith
So
EDM machine.
you would need a $500,000 EDM to make your $2,000 EDM. Yeah. Okay.
Yes.
Okay, so we're in
Let's do it.
we're in startup world, so we know a bunch of other founders. Like we're networked to all the other companies that are making like new cool stuff. And every once in a while, you'll see a machine design that's like, oh my God, they actually went with a strategy like that. Like they did something equivalent to machining a 1 meter by 1 meter block of hardened steel for their frame, stuff like that.
Right.
It's
Looking
fun.
at you, Pantheon. You guys know
Okay.
Pantheon, right? With the HS3.
We got to talk to them before. I think their machine, it definitely has some merit. It's an interesting
It's a
one.
gigantic machine. It's a gigantic metal cube.
It's
They're-
more like a C than a 3D printer. It is
Yeah.
pretty neat.
Yeah, their machine is what happens when you tell engineers to build a 3D printer and you forget to tell them that about a budget. Right? So they literally just build it as robust as humanly possible. Doesn't mean it costs a lot of money, of course.
Robust. Building robust stuff is fun. It's really cool
It's
to
just
build
expensive.
a plate steel.
It's skookum. That's the word, right? For the gigantic heavy duty stuff. Like if you look at the big like mining excavators, that's skookum.
Is that the word for the design style?
Yeah.
I mean,
Well,
that's
sort of part of it.
That's the colloquial
Canadian.
term from a singular YouTuber, and the term caught on. But yes, skookum as frig would be a technical term. Yes.
Oh, did you know that AVE built like a little simple EDM setup, and his
Yeah.
whole goal was to make it open source to put on 3D printers?
And that was years ago.
Yeah, and he just he's a YouTuber. He just didn't have the time to see it through.
It's a pain in the butt. That's why.
So yeah, it's capital intensive. It's time intensive.
Yeah.
Well, and that's any prototyping, but especially what you guys are doing, where you're trying to flip the script on what exists, and trying to do something different you're not making a 3D printer. You're making a wire EDM, and you're trying to sell it in the kind of the same market as 3D printing in the light machining world. And you're challenging the norm. And I appreciate the hell out of that, because there are very few people out there that, at least that are publicly doing this kind of thing, where they're like, so you love additive, but what about subtractive? How do we feel about subtractive?
It's all about like setting your constraints early on and doing first principles thinking. Like
Right.
before I designed anything, I opened up a notebook, and it's the first page in one of the first notebooks for my Rack Robotics like time that I was doing development, and it was called like EDM first principles. And I went through all the math. Like, these are the forces involved. This is the energy required. This is how voltage impacts the system. And this is how current impacts the system. And then from those like very basic formulas, that's how you get your machine constraints. Your machine constraints should not come from just saying, well, I like things to be robust and made out of steel. It should be like, okay, well, how much material do I actually need to resist the forces involved in this process? Because if you don't do that, what you're actually introducing is waste. Like, every piece of metal that goes on your machine that is not necessary is metal that is wasted.
Yep. Extra metal means extra cost, means extra weight, which just overall means it's, well, extra.
It's just more wasteful too. Like, that steel could have been used for something else.
Yep.
Right. Superfluous information is just not needed. And I think you guys are up to something really cool. I would love to, well, I'm going to ask the comments, but you know, you guys in the chat and in the comments, what do you want to see done with a wire EDM? Because I want to do a fun project. I just don't know specifically what yet. Because like, we just outsource all of our metal work. Like, but if we could start insourcing it, or go to a metal shop that doesn't have a wire EDM and show them this and get like kind of reactions and let them put it into use and that kind of thing, I think that would be very, very cool. But
Yeah.
I think Rack, you guys are really following the KISS principle, right? Keep it stupid simple and make it easy.
One fun idea we had would be making your own like Voron crossbeams. Have you ever seen those lightning cutout Voron crossbeams?
Yeah.
Where it's like an aluminum with a bunch.
Oh,
You could
dude.
probably make those, like, our goal is to make one of those on a beta wire.
Yeah, you could. It's not going
I
to
was
be
talking-
as thin because, I guess you would start with aluminum tubing, right?
Yes, yeah, you
Correct.
just do aluminum tubing.
You start with the square tube. Oh, damn.
Well, I was talking to
That's cool.
27 Printing, and I was asking him, like, how light do you think you would want a linear rail for your crossbeam? And I was just kind of playing around in CAD, like looking what parts don't need to be there that I can just cut out with like these 2D profiles.
Just like generative design
I was
it,
looking into that too.
but with
Yeah.
2D profiles.
I think
Yeah.
I got the mass down to like just under 13 grams for an MGN7 for his.
Jesus.
And then another idea we had was like making our own brushless stepper motors.
Yeah, that'd be cool.
Not
Right.
sorry, brushless.
Because you can get the main stator
Yep.
built without anything crazy.
Yep. So you could make your own custom motors. Like this right here.
Yeah.
It's a motor. This is a model of a brushless motor stator.
Yep.
Not stator, rotor.
Is
Stator. Stator.
I think it's a stator.
Yeah.
I have two
So
business
you
degrees,
wrap
man.
your wire
If
around
we're wrong,
this.
they'll correct us. It's a great thing about
Yeah.
the internet.
That one's made out of aluminum. You'd want to use laminated stacked steel, but
Right.
you can also wire cut that.
Could you just like put the steel into a big sheet and then just cut it all at once? Okay.
Yep.
That's so freaking cool.
Yeah, there are. It's not uncommon in shops to see like a bunch of sheet metal clamped together for a wire process, or like a bunch of like sheet metal welded together.
Yeah.
Like a
I think
spot weld or something.
EDM demonstrated that on his wire EDM, stacked titanium sheets and made a bunch of the same thing all in one pass.
Yeah, we're still waiting for Bax to reach out and talk to us.
Yeah, you know,
he does a lot of cool stuff.
I wanted to text him and just tell him to give me one of his power supplies, but I don't know if he would be willing to.
We can cut it in half.
Yeah. Not even gonna look at it like investigate it, just gonna cut it in.
Yeah,
Oh,
you guys are
bring
going to
that-
be EDMing some hot ends, I saw.
Yes,
Um,
yeah. So right now we have one from Luke's lab, the Tube, and then we also have one from Slice Engineering, their Mosquito Magnum Plus, I believe.
Yeah, so that's going to end up in a YouTube video. We're going to be slicing a lot of valuable equipment in half.
Destroying
If
huge
you-
amounts of it.
If you have anything expensive and conductive,
Yeah.
feel
We
free
can
to
destroy it.
Yes.
We can mutilate it, we can burn it, we can vaporize it, we can
What about
destroy all
diamonds?
So we want to get some polycrystalline diamond nozzles from, I think it's Diamondback. Thank you. Yeah. Because the polycrystalline diamond is in a matrix of cobalt, so it should be electrically conductive. I believe they EDM their nozzles.
Oh, we should talk about the ceramic guy.
Oh,
Rotoforge.
Yeah,
so
Rotoforge.
There's this PhD student who's building metal 3D printers for his to get his PhD, and he needed to fabricate a ultra high temperature nozzle for liquid metal. And so the way he did that was with a power core, and he bought conductive ceramic from McMaster-Carr.
And then glow plugs.
Yeah.
So diesel glow plugs, and he drilled high aspect ratio holes, a 0.3 millimeter hole through like 60 millimeters or so of glow plug ceramic
using a power core V1.
So
that's doing effing metal right there, man.
That guy belongs in Florida. He just doesn't know it yet.
Yeah. But so that was the coolest thing we've done so far. We really, really like Rotoforge project. I think that's really neat.
Wait, is Rotoforge in Florida?
Nobody should be.
Oh,
I don't know.
Definitely Florida man vibes. Cutting with oil on carpeted floor in his dorm room. So
it's a lot like Dominic Meffert.
Yeah. Just get the bucket.
I love the scrappiness of college kids. They're like the guy that was rebuilding an LS in his dorm room. Like, all right, fine.
I who's like refurbishing fighter jets in his garage, and he's using like Harbor Freight replacement parts. He's like the fuel pump gave out on his like 60-year-old fighter jet, so he's retrofitting in a Harbor Freight pressure washer.
If it's jank and it works, is it actually jank?
Until like your fighter jet falls out of the sky.
Right. Yeah.
Well, he's not at the point of it flying. He's trying to get first light still, all right? He's a long ways away from this thing flying, right?
I wait, like in 10 years, people are going to be using Rack Robotics tools to build like liquid fueled rocket engines in their dorm.
Yeah, that's going to be sweet.
One of our, I guess at this point, probably former staff, because I can't afford him anymore, is a student at the Ohio State University, and messes around with like Inconel and niobium and crazy stuff. I'm fairly certain you guys are talking with him. His name is Justin. Fairly certain you're talking with him, and if not, I will connect you all after it.
We're talking to a lot of
thousand.
We receive emails every day from like machine shops who want wire EDM machines from us. We get emails from like FIRST robotics teams who desperately want wire EDM to make like gears.
Yeah,
like good luck making a custom gear. Like custom gears are very difficult to get done. You need a gear hobbing machine for that.
Yeah.
We get emails from university students. We get emails from like people who are making jewelry who need a way to like very finely cut sheets of gold.
Some guy came in the other day. Our door is open, so if you're in the area and you want to say hi or bring something in to get destroyed with plasma, bring it in. The guy brought in a sheet of 14 karat gold, and he's like, "Can I EDM this? My laser's not good for this purpose." And we tried it out, and we were able to burn the gold for him. So we've got a few micrograms of gold in one of our vats over here.
It's our big investment.
That's the return.
That's how you get your funding. You start an EDM gold business, but you don't give them any of the dross. You just
okay. Actually, we've talked about like you could make a lot of money just like doing custom components with like desktop wire EDM machines. Like there are a lot of like niche, shall we say, pneumatic hole popper components.
Yes, yeah. Or pneumatic accelerators.
Yeah,
something like that.
For like parts that don't exist anymore that are ultra rare.
Yep.
And then there's also like machines. Like if you have a machine that is no longer in production and you can no longer buy replacement parts for, and you want to like scalp one of those off eBay, you could be paying like many times what you should for that like emergency replacement part.
Yeah.
Elevator repairs. You want to talk about a really funny niche industry that has this problem? Elevator repairs.
Yeah, it's not very easy to replace an elevator in a building.
Right.
You often just have to fix it.
Is this 20 years ago? Good luck finding spare parts.
Yeah, it's like, oh, but I just need this like sheet metal bracket to fix this $100,000 elevator.
Sorry, you have to walk. Like Or there's electronic or electrical crimps. If you're trying to
Yeah.
buy a crimp set
Ooh.
for like a Molex microfit from Molex, you're going to be paying, what is it, like $800?
It's $3,000 for like some of their hand tools.
So some of their hand tools are $3,000
for a hand crimper.
But it's like
It's
75
Molex, because
cents
F
deal.
you, go get it somewhere else.
Yeah, so like,
it's a good product. We love Molex connectors. We're using them in the power core. But
like if you want to make your own crimping dies, that's something you could do with wire EDM. So if you need like a custom die, or like they don't even make the crimp anymore, like a lot of Molex products are just discontinued.
Yeah.
Like there's a huge market for crimping tools on eBay, because eBay is legitimately one of the best places to buy crimping tools.
or if you just want to sell them for, sell these tools for $99 instead of $3,000, and it's 75 cents of steel. Okay.
It's the exact same like thing that happened to 3D printing. Like 3D printers caught on. One reason they did was because you can make niche parts that are incredibly difficult to get.
Yep.
And now it's just printing dragons, apparently.
Yeah.
So that happened as the market scaled.
Eventually, we'll get to the dragon machining.
Yeah,
portion
Flexi
of-
Dragon when on a wire EDM.
Well, no, you'll see people will just be cutting out those zero tolerance cubes that lock together.
They'll be.
I'm sorry, but I want to do
zero
that.
tolerance
Yeah.
I don't think your machine can do that, right? You guys don't have the precision? Yeah.
Well,
So,
okay, wait.
the
Pause.
Yeah, the thing about that, it's not one piece of metal. It's two pieces of metal that get machined independently. And locked together.
I
So,
know.
potentially,
it's a goal that we're working
we want
towards,
to try it.
and we'd love to hit it. Like that'd be
I mean,
that'd be awesome.
if you give yourself a couple of tries and you dial in the machine,
Mhm.
there's no reason you couldn't.
Yeah.
Right. Like if you said, oh, the first time it came in like two tenths too big. Okay, cool. Like just mess with your CAD a little bit.
Yeah, it's not impossible. Like I do think that 100 years from now, maybe I don't know, between 10 and 100 years from now, people might be making those zero tolerance cubes in their garage.
Like just for fun.
Definitely
Yeah.
closer to that.
I mean, I definitely would. Right? Like, I definitely would.
I really want to see the zero tolerance cube version of like a Rubik's Cube, where it's just like a puzzle of zero tolerance parts that you have to like, like puzzle boxes are cool already.
This
Like,
team
just
with
a-
puzzle box.
Right.
It's just a cube.
Like, get
puzzle box.
3D printy one of these, and he's like making all these new puzzle boxes, but it's all zero
Imagine-
tolerance fit stuff.
That in your garage, like your zero tolerance puzzle box that you make in your garage on your Rack Robotics like budget wire EDM machine, and then like sending it back in time to like 1940. Like that's what crashed at Roswell, was some
Yeah.
dude's like hobby keychain.
Right. Yeah, it's his fidget toy.
Well, that and like you go far into the future where the United States destroys itself, the rest of the world does too, and then there's just a cube sitting in this pile of rubble, and people are like, "What the hell is this?"
This must have been the peak of their engineering, and it's like
it's
it's a
fidget
dude's
toy.
Etsy store.
Yeah.
Yeah, it's just like a bunch of like cubes in an Etsy store box, like bin bag, and they're like, "Oh, yeah, no, this is just common."
Yeah.
That'll be the day, right? That'll be the day. I have gotten 3D printers from estate sales. I often buy them because I don't want somebody else to buy it and make it my problem.
Nah.
FLQ309 with the $5. Thank you very much. Saying, any chance by any chance, are they thinking about EDM drilling for the future?
Yeah, you
Okay.
can do that already.
Yeah,
Yeah.
The
We've done.
future! Oh.
So like future like 3 weeks, I should be releasing something like that.
yeah. Definitely. And then I also had an idea for like an EDM hand Dremel, like a tool for like engraving, like
Yeah.
just by hand EDM. That'd be fun.
That'd be fun. Yeah.
Like the little demo that you had at
But more
at
technical.
Rocky Mountain,
Yeah.
but like way more better.
Slightly
yeah.
more developed. Yeah.
Yeah.
Like less like it seems like it's gonna kill you.
Right. Yeah.
I mean,
I
that's
put the-
generally my desire, is not to be unalived by the work that I do,
Yeah.
There's
Drilling.
a lot. There's a
You
lot
can
of real
definitely
work
do
on it.
drilling. We've done drilling. It's a
Yeah.
lot of fun.
Yeah.
You do
Actually-
want closed loop control for that. So you just want to be able to retract your tool whenever your spark ignition rate gets a little bit too high, and you can do that with the feedback from the power core.
Yeah, I built a hole popper for burning broken taps, and I bought a bunch of $1 Amazon M5 taps, so I can screw those in and whack them with a hammer just to like
Make
get
sure they
going.
break.
Yeah, break the hell out of them.
just go full force it into a blind hole. It'll figure itself out.
That might show up in the video. We had some ideas on that one. That'd be a lot of fun.
Yeah,
And then you were
we'll-
using the EDM to just burn out the tap?
Yeah.
Oh,
Yeah,
that's
and
super
we're
cool.
gonna stick one of those onto like a desktop positioning arm, like a little suction cup positioning arm, so you can just like move it around your work and like cut out taps.
Yeah.
Now, see, that's a valid use that most home gamers could get out of that. Because who here that owns a tap and die set hasn't cracked a tap before?
That's why EDM was started.
Yes.
Really?
The very first application of EDM was drilling out taps from tanks.
Yeah. Because like you really want to scrap a like the hull of a tank because there's like one critical tap that broke.
Yeah.
And so this happened during the Second World War. They needed a way to rescue these pieces of work that were going to go on to planes and like aircraft and tanks. And so they developed like a really, really janky wire EDM tap removal system that used the energy from the sparks to also actuate the system up and down to do the closed loop drilling.
So
And then
freaking
eventually that evolved into like a doorbell ringer.
Yeah, some of the earliest CDs.
Yeah,
doorbell ringer.
To do the on-off like high frequency functions. And then that turned into vacuum tubes, and then the Russians started developing it. And then
Well, it was originally discovered by accident by the Russians around World War II. They were trying to prevent the magneto contacts in their vehicles from getting destroyed over time, and that's when they discovered, like, wait a minute, there's sparks happening here. Maybe we could use this for something else.
Yeah,
I'm pretty sure it was also independently discovered around the same time in the U.S.
Yeah, everything was sort of primed at that period for people to discover that sparks removed material, and then as soon as they did, they started finding applications for it. And I personally think that like the consumer and the prosumer and like the like $5,000 wire EDM machine, that's going to be a bigger market than like the legacy wire EDM machines that are used in heavy industry. I think that there's going to be there's a lot more.
You're going to see the switch.
Yeah, you're going to see a switch where that like in the same way that the consumer 3D printer market is comparable inside like the industrial 3D printer market.
Yep. It's the same way. Like, you know, I started 3D printing in 2008, right? You had RepRaps or you had expensive. That's it. Those are your two options. Oh, you wanted filament? $60 to $80 a kilo. So what did we do? Well, when the Fillustruder came out, I bought one. Was it good? For its time. Was it dimensionally accurate? Hell no. Did it keep crap from getting into your filament? Hell no. Was it fast? No, but neither were the printers. So, like, yeah, you could make a kilo in about a day. Your printers could not go through a kilo in a day. It was not possible, right? Our motion systems didn't exist, but as the technology's gotten better, filament's gotten to a point where I don't think I've used my Fillustruder in 5 years. It just sits because there's no real reason for me, unless we're playing with like really weird polymers like PCL. There's really no reason to use it. So it becomes now, it went from we need this to make this kind of business affordable to, well, now we just need this to mess around.
Mm-hmm.
Yeah.
Right.
And it's like as we scale and as the market grows, we could get to the point where the consumer market is the primary like driver of like wire manufacturing. Yeah. Like most wire might be going to the consumer market rather than the industrial, and then the price will drop.
Yeah.
Right.
And one of the cool things of going through like this whole RepRap process again is that we can see, like, we can look back. You know, John and I were both working on RepRap stuff back in high school, like, and, you know, previous to this company. And I guess now here again, RepRap sort of with EDM, we have that roadmap to look at, and we can see, okay, what worked for them, what didn't work for them, and what worked for the companies that made it happen. Like, what did they focus on? It's user experience, their skill reduction, things like that.
Yes.
And so being able to look at that to guide ourselves is going to allow us to move faster through the RepRap cycle.
Yeah, so we're definitely following that same roadmap. Like right now, we're in the RepRap phase where we're releasing open source kits, and then like as we develop, we'll have turnkey machines for people who don't want to build their own wire EDM machine from scratch.
Yeah,
and eventually we'll build the closed source one that sells all your data.
Yes, exactly. So give 5-10 years.
Well, let me set my stopwatch.
Yeah. So
the 10 years sound about right for the villain arc.
Yeah, the community disrespect is build it now, and then you can release it when we do that.
Yeah, we'll get taken on by like private equity. You know, they'll tell us how we should actually run our company.
Yeah, that's fair. Once you do your full sellout to private equity, that's it.
Yeah,
Yeah, you're just the puppet.
And we'll say, sorry guys, that's
you don't have a Cybertruck?
Once IDG Capital buys you, that's it. It's over.
In front of my house. What was I supposed to do?
That's right. Classic.
Sorry.
And so Underhill's asking what the price target is, but the price targets are public, right? The Beta Wire 4 is price targeted at $2,000 at the moment, right?
Yeah. And then that includes the power core, which is $400.
That was something that we saw might not have been understood on a recent Hackaday article. People thought it was $2,000 plus the power core price. It's just $2,000. That includes the power core.
Yeah.
Look, if they want to pay for another power core, you're happy to sell it to them, though, right?
If you buy another power core and you just
send it to
happen
you.
to have one laying around, we're not going to be mad at
Oh,
you.
We'll take your money.
We were at our Murph. And
Dude,
we were at our
at our Murph, but this is not an uncommon theme. When we tell people like, oh yeah, this system's like 500, and they're like, wow, $500,000. The world's really changing, man. And I'm like, no, it's $500. Like, no, it's not.
Oh, inflation. Yeah, inflation.
Yeah.
Politics.
Like,
well, and then like the investors here, they're like, oh, maybe we could sell it for $500,000. No, that's not the point of the company. The point of our company is that we're going to sell tens of thousands of wire EDM machines for like $5,000 each.
I think there's money there, right?
Looks back at Prusa printers. Yeah, there is money there. That
was not intentional. I just didn't hear it making noise. I wanted to make sure it was still running, or it had finished.
Prusa at peak was selling like 8,000 of those printers a month.
I don't think it at 10.
Yeah, and if you do the math, I think they're like $1 billion company.
Prusa is still growing, and that's the funny thing. People are like, oh, bamboos. There was a YouTuber that said, Prusa's the next BlackBerry. You don't understand their business model if you think they're the next BlackBerry. It has
definitely transition to B2B from like a B2 consumer thing.
Yeah, because where's the money, people? Where's the money? It's not in the makers. Why did 3D Hubs stop working with makers? Because it's not profitable. Why did they sell out? Because it's not profitable to work with makers, right? Prusa still sells to makers, but we love all of them. We have 14 now, 14 Prusas, and they are the bulk of our print farm. Why? Because they just freaking work. Does Bamboo take away from Prusa's market share? Abso-freaking-lutely. Abso-freaking-lutely. But, do they care?
Have you seen their
That's the question.
Have you seen their like almost like drawer mounted print farm where they have like a bunch of Core XY units on like a big rack?
Not only have we filmed with it, and that video will be coming soon.
Awesome.
Cool.
I'd love to see it.
Yeah, we want to see that.
Right before Smurf, we went out to Prague, because if I'm going to the UK, it was, and Prague, the Czechia or Czech Republic in general is very affordable for Americans. The US dollar's very strong. So yeah, we spent a whole week out there. We did a couple of days of filming. We have over 250 gigs of footage from Prusa.
Let's go.
Yeah, so there, and I have long hair back then, which is going to be really weird for me. So I'm hoping that we just go back and do it again this year. But we have not released that video, and it's been like 6 months since we were there.
And like honestly, Prusa started focusing on like enterprise solutions, and they put the RepRap stuff on the back burner. That's fine. They've already done so much community. Like they've done more than
this
their
community wouldn't exist in the way that it does without them. Period.
Right. So
we wouldn't be doing what we're doing without them.
Right.
Prusa's been a huge inspiration to us.
Yeah, and I think that there's a lot of merit to like the RepRap to enterprise pipeline. Like it's great. Like, hey, release stuff open source. Build up the repertoire of tools that makers have available to them and that like students can use. And then like once you have your company built and you have a lot of like experience in the field and you can build an enterprise machine, do that.
Yeah. And the really nice part about that transition is that the contributions that are made are unmutable.
Yes.
The technology is now there. It cannot go away. And that's to me so far that like John and I have been working on electrochemical and electrical discharge machines for about 5 years now. And for me, it's like, okay, I'm really close to like that goal that I set out to do like 5 years ago,
right,
as far as like that tech proliferation thing.
Make an open source machine that can cut metal.
Exactly, and do
Right.
it well. And
Yeah, and we're with the beta wire, we're very quickly almost to completing that goal. And then when we have like LDO on the kit, and we have distributors like Fabrico distributing that kit, like we've hit the goal. Like suddenly this technology that wasn't available to people before is now available to makers.
So David Connor Shover is asking operational MBTF on your power cores. I believe that's mean. I think it's NTBF, mean time between failures, on the power cores. What's the expectation, do you think?
That's going to depend on your kinematics.
Yeah.
More reliable kinematic systems will have more reliable cutting.
Yeah, and so the failures are not in the supply itself; it's in the wire. Like cutting too quickly, failure there, and then
Your wire will snap.
yeah.
So I think he is asking about the actual power supply itself, though. Like, how many hours are we expecting out of the power supply?
So I think we've killed 1 or 2 power cores so far, but we were misusing it in an extreme manner.
Yeah, so the way you kill a power core is you short it for a long period of time.
Yeah.
But like at Armorf, right? Like the beta wire ran both days. The demo is like, it's super fun to do like hand drawing stuff.
But it's
But that
nasty to
is-
the power supply.
A
torture
torture task.
Well, because
We destroyed one doing that, and that was from it's a solid brass rod, and you're making that hard connection. You've got a really, really nicely close.
But we
circuit there.
destroyed that before day 1.
No, it was.
no, that
in the
was a
middle of
different
day.
power supply. That was
Yeah.
the other one.
Oh, that was the dead
Yeah,
one.
so like the way that we've killed power cores is shorting them with brass rods for extended periods of time.
Mhm.
And then if you don't do that, you're good.
Yeah,
And that makes
the
perfect
wire
sense.
acts- The
Yeah.
wire acts as a bit of a fuse.
Yeah. So if
It's hard. It's
Yeah.
really hard. When you're using the wire system, it's really, really hard to mess up the power.
yeah, and that's one of the reasons why we love wire, is because it's sort of like if you do, it's forgiving, and if you do make a mistake, you can just rethread the wire through the
Yeah.
system, and it's
No big deal.
Yeah.
No big deal. Well, guys, this has been super cool. I am looking forward to following along in this project, kind of seeing where it goes, and at some point building one on the channel. We'll probably do it live because I'm a glutton for punishment, apparently. And be able to, because like I live in a port city, right? And that means we have a lot of manufacturing out here. And so to take it over to manufacturing facilities, and like my buddy who has big wire EDMs, and put in his office and say, what do you think? Right? Let's get an honest opinion from someone who runs probably close to $1 million of wire EDM. I think that'd be super cool, because then you get a real opinion from someone who is an industry expert on this kind of stuff.
Mhm.
Yeah.
But any final thoughts do you want to leave the folks at home with before we call this one a wrap?
Don't
we-
need battery.
Don't need batteries.
don't actually throw these into the ocean to recharge electric
Yeah,
eels.
please do not
our
actually
exclusive-
dispose
yeah.
it into the ocean.
That's our thing.
That's us.
We have
Yeah.
the contract with the EPA for that.
Yeah, we'll sue you.
We'll have to take
Um,
the royalty.
It's a process patent.
Yeah. But in a serious sense, I feel like compared to someone who doesn't do this, we're kind of closer to expert, but there's definitely, we don't know everything about it. So if you know more than us, please let us know.
Yeah.
We're always learn more about the process.
It's the beauty of open source. Join their Discord. Their website is linked in the description. But I think we are going to call this one here. We've done at least 2 hours and 15 minutes of good audio on this. So 2.5 hours deep. Thank you all for coming out. This has been episode 187 of the Making Awesome podcast. And you all know we're going to go bother Steve Builds. We're going to send you over to Steve Builds. Go check him out. I think he's working on the black box build. I think he's on build stream 4 of it. But check out Rack Robotics. Links are down below. Leave a like, subscribe, all those things you're supposed to do. That's all we have for you all today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one.